You ever see a stream with like a starting soon dialogue? That's like, stream's gonna start soon. And there's like graphics up. Like I can do that, but I got a lot of webcams running. So why don't I just sit here and hang out with you guys for a little bit until we actually get on topic? That's essentially what it is. That's all the start of stream is. Oh, this is still, hold on, I need to get rid of the non-line. I need that cutoff to be like right at a line. I think that's right. Yeah, a little bit like that, yeah. It allows, so instead of getting into it and explaining what I'm doing to 7 to 11 people, I need to wait until there's like 30 to 40 people before I actually get into it. And then more people know what the hell's going on today. I also forgot to update my title, so some people think I'm playing Long Drive if they're just running off of email. Actually getting stuff in the garbage can today. All right, let's see here. I need to make a little bit of room so we can have space to think. I'm debating on what to do for Saturday. If you know, we're gonna have Julian here on Saturday. Julian is here on Saturday. So the question is, am I gonna make him another mic pack and he'll go through the exact same filtering that I do, only with a different microphone? Or do I leave him up to his own devices and he'll be on his own little directional mic, his separate directional microphone? He's gonna be here, he's gonna have his iPad and maybe some musical stuff, and he'll be doing ambient noise and things in the background while I build him a thing. Yeah, talk about how my mailbox is stolen and stuff. Yeah, that's where we're at. That's where we're at. Man, I'm tired. I thought I got enough sleep last night. I think I got to bed at 2 o'clock. Woke up at a decent hour. Don't feel like I slept. I took some Advil before stream. We'll see if that either makes me fart or if it makes me actually stream like a normal human being. Usually I'm okay for this kind of stuff. We'll see. I don't need the power supply on this. Oh, this mix got dark suddenly. It got dark. I had a negative amount of sleep. You said you were doing a short stream because you had work. What did you do? You said this, you liar. I saw your title. You liar. Fell asleep at the dentist's waiting room. Oh god. What's up, Pyra? Let's turn off the thermals. from readily available capacitor values. Table below assumes a linear pot. Ideally, you'd use an analog. Antilog. Oh. No. Copyrighted song. Too bad. No, this is not for the gaming mic. The gaming mic you guys heard on Saturday. I think that's okay. I just flipped my bass up a little bit on it, and I think we'll use that one just with the mixer, just vanilla, so I don't have to lapel myself when I'm sitting at the desk. The lapel is important for the shop because I'm getting up a lot, moving around a lot. At least typically when we have a laser working, which we're gonna work on Thursday, I promise. We'll get to Fusion 360, we'll do some 3D modeling, and then I'll be able to print it out and have a hot end finally. Julian is here on Saturday, by the way. I'm gonna announce that quite a bit today. Julian is here on Saturday. Hooray. And we'll try to figure out our audio setup and get this all done. It's a very simple thing to build. It's a particular piece of musical equipment that we're gonna build. Pretty simple. So we'll see. Yeah, what scares me about the gaming mic is that it sounded exactly like the lapel mic unfiltered. So I'm wondering if I can plug the lapel with none of the filters I'm building on it into that mixer and get the same sound out of it. It's a little bit sensitive to like scraping beard hairs and stuff. But like getting this sound out of the mixer might be doable without all the filter stuff that I want to build today. We're still gonna do the filter stuff. It's content. I'm having fun. It's neat to do some analog audio stuff. So we'll do that still. I'll still try to build it and build the circuit and everything because I think it would be really cool to have all the audio filtration stuff in that the Elite Core. What's up, Nez? How you doing? Yeah, put it all into the Elite Core box right there. He is practically the Lemur King. Yeah, he's close to that. Julian's an old friend of mine. He's an old friend of mine because we're both old now, I guess. And also he's a friend of mine since like a million years ago. I think we dated the same girl at one point. But yeah, he's a friend of mine from millions of years ago when teenagers would hang out in front of coffee shops in the middle of the main line. No, it's a Pepsi. It's just, no, actually it's Coke. It's Coke for once. Usually I buy Pepsi. Somebody else bought this. Yeah, I stream like afternoons, so we get a lot of foreign language people, quite a lot, and that's okay. If you're, usually you guys are like, oh, I am so sorry for my English, and then speak completely eloquently. So, whatever. You guys are good. I've only seen Julian once 2 years ago. Yeah, it's hard for us to come up with a good project to get him in here. I would love to have him as a regular on the stream. He knows how to do radio, but he used to work for one of the local college's radio stations. I once called into his radio station show, and I was too nervous. I didn't have any personality. It was ridiculous. But yeah, he knows the scoop. It's just tough to get him in here, you know? Oh man, no, he's just carte blanche. Like, any DC movie is good in his book. That's it. So, you can't convince him otherwise. He doesn't care for your arguments. He just likes them. It's fine. They're not good movies, but who are we to judge his own preference? Stream time is perfect for an afternoon chillin' watching in Germany. I appreciate that. Hey, man, if I didn't do this in afternoons, I would waste my days, so. Just be happy you have a 3D printer. Yeah, it's true. 3D printers are annoying, though. They're tough. The slowness means quality, though. That's the thing. It's like ambient noises in the background right now. Ambient background noises. I'm not using the mixer today. If you guys didn't know, if you guys are new, if you saw me playing Long Drive and are like, oh, I'm gonna stick around and watch this dumbass. I'm actually not listening, or on your burp. You are not hearing me through the mixer. This is my lapel microphone, and it's got a little mic pack on it that runs through some OBS VST filters in order to give you professional sound. Now, these are free, so you can't save any of your settings. They just persist. So what we're trying to do today, if you're new to this project, is we're trying to replicate the effect of these filters on the lapel microphone so that I can plug it into the mixer and I can use that mixer. Now, it's possible that I just haven't adjusted the mixer properly, because I got an expensive normal microphone. It's like a $300 microphone, right? And you may gawk at the price, but that's like entry level. It's not unheard of to spend $1,000 on a microphone. I don't do that. I'm not gonna do that though. I bought an expensive microphone and I plugged it into the mixer and I got just about the same sound as the lapel microphone. Overly sensitive, you can hear scraping of beard hairs together. It picked up absolutely everything in the room. It did not filter out my voice the way that I would like it, like RTX voice style. It has a noise gate on the mixer too, which I don't like. You can see I'm just using audio level gating here for the compressor. So what I've done is I've gone back to the drawing board. I've gone back to the amplifier pack that I built for my lapel microphone. You see, what you could do, what some people do is they buy like a little transformer pack, and then you can plug the lapel microphone into a phantom audio microphone plug, and it will power the lapel mic and it will amplify the audio coming out of it and send it back on the XLR. That's all well and good, but I didn't do that. What I did is I actually made an analog circuit, an active analog circuit, based on the Elliot Sound Projects archives. He's got a wonderful little lapel, little electret microphone amplifier, and I committed that to a circuit board, and I put the circuit board in the little metal case, and now I'm wearing that on my belt, and it is amplifying my voice perfectly. But it is a very one-to-one amplification. So if we can replicate all of those filters and it can just exist inside of the pack, then if I have a co-host, aka if I have Julian here, I was hoping I had time to finish this stuff before Julian showed up, but we're doing this on Saturday anyway, regardless of what my setup is like. What I can do is just plug in another microphone and they will have the professional filtering that I have. And hopefully we don't get two voices, you know, colliding with one another coming through the microphones and stuff like that. So, I don't know. We'll figure it out. We'll figure it out tomorrow. We did in the past, even if Julian has to be on an extremely directional microphone in front of him. But yeah, I was hoping to get all of this wonderful stuff done with analog filtration. So today, we're going to try out a different filter. And I'll explain this again when we actually start. Yeah. Almost an engineer. It's Tuesday. What? This holiday has messed my track of days up. What holiday? What are we talking about? Thank you for the 18 months with a prime, nonetheless. This means that almost an engineer is organized in their life enough that they don't need to be reminded, and or they just watch the show and notice that they don't have a sub going and re-up it. Those prime subs do not remind you, and they don't auto-update. So you guys with long streaks with the prime subs, mwah, I love you. It's amazing. I keep doing the chef's kiss. I just keep doing it. We're gonna be doing some soldering today. A little bit of soldering. Nez gifted a sub by Baldisos. Baldisos, thank you so much for the gift sub. I appreciate that. That's mighty nice of you. That's mighty nice of you. How's she going, eh? Yeah, we're doing all right. We're doing all right. I'm waking up. As I get more into the stream, I'm gonna wake up a little bit more. We got the desk lights off of my noise floor, so the O-scope finally works properly. Oh, it took a week off for a uni paper due Thursday. Normally where it's Tuesday because of the shit at work, and my prime sub expired on Thursday. Blah, 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 blah. Got it. Okay, so things are confusing in your life. Well, thank you. Thank you for the prime. I appreciate it. Your dedication. You took a whole week off of work just so that you could resub with prime. That's impressive. That's the kind of dedication I want to see around here, right? You guys quit your job and your life and go live in the woods for a month. To work with though, because if you mess up one of your traces, where the hell is it? Do your work. Do your homework. I'll be here. Burm, burm, burm. This is one of those songs that relishes in kind of a sour note. I'm reloading Streamlabs right now. I don't know how much Streamlabs is doing for me, you guys. You know, the alerts, I could make much cooler looking alerts, or at least I'd have them look like that, where it kind of like fades in and does a weird thing. I could do that with multiple layers in a different tool. I don't know if Streamlabs allows better animations these days. They might. Should look that up. Leo ran board. What is that? How much of the cut do they take of donations? Stream Deck Animator. Ah, holy shit. Yeah, so it's got like storyboard animation kind of stuff. Interesting. But it does alerts and stuff. Like so Streamlabs I got because of the donation button. So when people donate, I get a better cut of the money that's being donated, and it helps support Streamlabs, which then runs these tools. Yeah, it does everything but donos, and I guess I could like, I don't know how I would alert donos. I don't know. I don't know. In a way, I wish my computer would completely crash and burn so that I could reinvent all these tools that I use. There's also another service like Streamlabs that I was looking at that had better animation stuff. Yeah, there's probably a way. I mean, I could come up with my own tools, like with the API too. I could just use the Twitch API, but I don't want to make that big of a processing script. I'm sure there's a way. Maybe not. Pixel chat? Yeah, see, I don't know any of these. I just set up Streamlabs and I let it stay. I tend to keep my notifications fairly minimalistic. We don't have sounds associated with the notifications, and I like it that way. I don't want you guys to be playing the casino where it goes blood-oop, you know. Oh, I put my money in the slot machine. It made a noise. I don't play that game. Yeah, some of the I mean, I know Djibouti Show plays into that in a very big way. Like, you donate particular amounts of money and it will play funny sound on stream, which is cool and all. You know, they've done a really good job of that. You know, if you wanna hear their little rendition of "I've got 5 on it," you can $5, right? I could do that, but maybe that's for another day. We put useless stream points into that. That's my only noisemaker. We'll play that game one day, but until then, yeah. We keep it minimal. I have enough stuff to interrupt me that I've intentionally built in order to interrupt me. Man, every time I lose a beard hair, I have a little bit of a sad. That one's getting in my mouth, though. What's TextMate doing? Until dawn. Oh, it's a VOD. Guess I'm ready to start soon, right? Ha! That's great. I still have some ideas and stuff like that. I'll do that, like, I don't wanna leave it up to you guys a lot. I do have some idea of like, things that I wanna do. You know, more channel point sounds. I've got those other noisemakers that I took apart. I don't know where I put them, but something other than just obnoxious farts, you know? Have like other sound effects maybe. I just haven't had the time to do it. Who's doing predictions already? Who started that? What the hell is this? Taking ownership of this. What am I looking for? Pew, 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 pew. Yeah, there's, I guess predictions don't end up on screen in any way, huh? You guys are getting psychologically manipulated by my mod. He's using you for his experiments. My God. My God. The horror. Okay, yeah, should we get started? We gotta build an EQ today, so we might as well do it. So, let's actually start the stream. Just fade them out and then play my intro music, which I don't have. Yeah. Setup starts soon. There we go. How's everybody doing today? It's Tuesday already. I say already, but I was like pretty bored on Monday. I was thinking, all right, you guys can't just like let me talk. Pretty bored on Monday, so I was thinking about whether or not I wanted to stream on Monday, but I just held off. Bit of a gap in streaming there, right? Well, anyway, I want to work on this this audio circuit. We're having a pretty good time of this so far. There've been a couple little hurdles on the way. Kind of figured out what I was doing wrong and corrected some circuitry, and now we're steaming ahead with analog audio. So what I've got right now, what I'm talking to you guys through, is my lapel microphone. That's not what I used for gaming. I got a new mic for gaming for my birthday. It was expensive, but it was my birthday. It was like a fancy pair of shoes, but nobody goes out anymore. So I got a microphone because everybody's talking on the internet now. And I put that through my microphone. And I put that through my microphone. Or through my mixer. And I got that all tuned up. So now that that's all tuned up, I'm starting to have doubts about whether or not we need any of this filtering on my lapel mic. You see, my lapel mic is a bit of a different system. My lapel mic does not go through any kind of a mixer. Most of these streamers that you guys see online, they are using some kind of a mixer that has voice, like EQing effects and stuff like that, right? I'm not doing that. My lapel microphone goes through an amplifier that I committed to circuitry off of the Elliot Sound Projects pages. He does a lot of analog audio stuff. He's really good at what he does. This specific microphone amplifier takes the signal from a lapel microphone, takes phantom power from the mic powering stuff, whatever, and it amplifies the very small signal from the lapel mic onto a differential XLR, right? So we're extracting phantom power and then we're putting analog audio onto a line. It is a very one-to-one mixer, or sorry, one-to-one amplifier. It's a one-to-one amplifier. It uses an op amp, uses two op amps, and it just reproduces sound very well. It's also kind of an expensive lapel microphone. It's from a friend of mine. I asked him if he had any extra lapel mics because I wanted a bit more freedom in the shop. I wanted to be able to move around. And he was like, yeah, I got whatever. I got like a spare that I could send you. It's not like, it's kind of like we don't do anything with it. It's just been sitting in a cabinet for years. I don't really like the way it sounds. He sends me this thing and I look it up. It's a Tram TA50 lapel mic. It's like a $300 lapel microphone. You can get them for like 150 used. And I did. I actually bought a spare. You always got to have spares in this business. Man, it was an expensive little piece of kit because it's meant for like movie audio. So I had to do it justice, and I wanted to build something that would give me good sound out of it. My options were to buy a like $100 transformer, literally just wires wrapped around with ferrite core, wires wrapped around a core that was way too expensive, but it would put my audio onto an XLR circuit, or I could spend just about that much on a wireless lav pack, which I would have to keep charged, would be susceptible to interference, and I could accidentally take you guys to the bathroom with me. Or I could make a project out of it and build something nice that gives me near professional audio out of my near professional gear. So I did. I put together this whole mic pack thing. So now I have come, well, okay, so I built the mic pack thing, and then I plugged it in to hear the audio coming out of it, and you could hear everything. The flat audio response of the tram microphone was well in effect. There were too many frequencies coming in. It was too sensitive for the highs. I was literally able to hear myself do this. You're not supposed to be able to hear that. That is two beard hairs rubbing together. That should not be audible, but it was extremely audible. It was loud. So what I did in order to alleviate you guys from having your speakers like blow out and punch you in the face while listening to the show, and in order to give myself, my dulcet tones, a chance to get, wow, it's Philip J. Fry hair. What the hell is going on with my hair today? In order to be able to hear my dulcet tones, as well as not have your speakers, explode, I put my audio through two filters, and the two filters are a compressor and an EQ. So if you guys are familiar with audio, fuck off. Those who aren't familiar with audio, an equalizer, in this case, we're taking frequencies and we are increasing them and lowering them in terms of the makeup of all the waves that are coming into the microphone are unperturbed until they hit this filter, and then they are either raised or lower in comparison with other frequencies that are present, right? This is everything. This is the view that we're looking at here is the Fourier transfer of the audio frequencies. So what we're looking at on one axis is frequency, and on the other axis is, you can think of it as volume or gain. So we're looking at all the different frequencies that are coming in. We're not just looking at the raw audio. And then this filter then takes the frequency makeup, and it either enhances or disenhances it, right? So that's that filter. I want to reproduce that filter because that's how I get the magical audio out of this microphone. That's how it sounds normal. Now, the reason that my volume isn't exploding, you guys, is that right here we have a compressor, and if you look at the compressor, there's this diagonal line in the background. We're looking at volume on a logarithmic scale. So the further up this thing goes, it's much louder up here. Just know that it's on a logarithmic scale. And then we got gain here, right? So at a particular amount of volume, I am raising the volume above this diagonal line, but at a particular volume towards the bottom, I am lowering it to where you can't hear it. So that if I just sit here and I like scratch my shirt, you can't hear that. I can't quite get that out of the mixer. It's close, but it uses a noise gate, and people think that noise gates are better. They're not. The problem is, what is noise? A rhythmic sound counting as not noise can get through a noise gate very easily. You can use AI to make a very nice noise gate, and to do all of the plucking of the audio, voice frequencies out of the mix. So that's where you get things like, what is it? The RTX sound, right? Everybody wanted me to use RTX sound, but the problem is, I use like power tools here, and I need that little bit of background noise mix in order to contextualize what I'm doing. Like if I start drilling into something and I like cut my finger and I'm like screaming, I don't want that to be silent, I want you guys to be able to hear the power tool that I'm using. So noise gating is dumb, and it can sometimes cut out the stuff that I don't want, or that I want, and not cut out the things I don't. What was it? What did he just say? I don't get it. But anyway, that's part of the audio setup that I'm using here. I want to replicate this, but inside the mic pack so that I can plug the mic into whatever I want without these filters, because these filters don't even save their own settings. If I touch any of the buttons on these filters, I might be throwing out my entire audio setup and have to reinvent it again, which I am absolutely not excited to do. All right, are we going to be right outside of the window? I'm gonna have to close that. All right, give me 1 sec. Somebody just floated by the window. No. God, come on. Whatever, the sun's coming in anyway. Now I gotta turn the fan up because it's like 60 degrees out. All right, so now we got more fan on. Hopefully that gets filtered out of the audio as well. Okay, so anyway, that's a little primer on what my audio system is in here. I use VSTs, and the VSTs are not paid, right? Thank you for the follow. The VSTs are not paid for, and so when the VSTs get messed with, they will junk their settings. They'll throw out all the settings, and these are rather important to me. So what I'd like to do is build them into the lapel pack that I wear on my belt. And that's a bit of a challenge because it's a bunch of analog circuitry. Now my filters are digital, but this is analog. Now what I could do is digitize, make the audio digital. I could make the audio digital, and then I could put it through the filtration that we would design in software, and then I could pump it back out as analog, right? But I am going to start with the analog method of manipulating all the sound through resistors and capacitors and op amps. And we'll see what kind of result we get, right? And if I can't get it quite right, maybe we'll have to go to digital means. It would be kind of cool if I had an FPGA in here, and then I could come up with all kinds of fancy filters to do it. FPGA is not quite RTX audio, but it is pretty nice. It would be an interesting setup, to say the least. But this isn't stuff I can sell, unfortunately, because I'm not inventing this from nothing. We are following the venerable Elliot Sound Projects in order to put these together. But so, yeah. The other week, this feels like squished. Does that feel like the aspect ratio's off on this monitor? No, maybe I guess it's all right. We follow the venerable Elliot Sound Projects, and I highlighted a couple candidates here for our modification. Project 93 is the mic pack. Project 93, but we have to split off the EQ at a particular location. And so this is what I came up with. Let's delete this. So I came up with this right here. The EQ goes right there. And we had to split this off because the circuit was rearranged in a weird way. Elliot has a weird way of putting his schematics together that I don't think quite, they're not as easy to read as I think they should be. Basically what he's doing here is he's creating a offset of about 7.5 volts, and then your analog audio goes on that, right? So what he's doing is he's powering the mic pack over here with the 10K ohm resistor that goes up to the 10 volt power. So he's powering the lapel mic, removing the DC component from that wave that comes back out of it, comparing it to, well, with a 7.5 volt, I guess he's introducing, or no, he's creating. It's weird that the 100 kilo ohms is there. Anyway, 7.5 volt like midpoint for that wave, putting it into a comparator circuit that amplifies it, then puts it into either direct output at a gain, like it's a gain of like 6, I think, puts it at a direct output, and then this one inverts it and puts the inverted wave on the other XLR output, and that allows common mode noise to be deleted. In phantom audio, though, you also have a DC level on these pins. So you have a comparison between these pins and ground that should be around 40 volts, filtered through a Zener diode to be 10 volts. And then you have your waves that are also on these pins. So what you can do is you can put those waves into a transistor, and that transistor can then fight the wave and stabilize your power. So you have a stable 10 volts coming out of there, and then you have your audio channels that are inserted on the line over here. So what we're able to do is cut off audio so that none of the waves get out, and put this on the scope so that we can see the audio coming out of here and we can adjust it appropriately. So we can look at that frequency component and we can see how the filter reacts to the different frequencies that are present on the line. We built an EQ, and we built an EQ based on another Elliot Sound project, which is Project 149. Hey, not a bag. So Project 149 involved a graphical EQ, the difference between parametric and graphical EQs. Probably not the first time I'm going to explain this today, but with a parametric EQ, you have your filter going into another filter, going into another filter, going into another filter, and then coming out on the outside is your waves, right? So that means each filter along the line gets whatever modified wave the previous one worked on. So you get all the frequencies in, you look at the specific frequencies that you want to modify, and you put them back in. So it's taking out a piece of your audio, putting it back in, and then hopefully everybody down the line gets it right. So the more filters you put in to a parametric EQ, you might get some weirdness on the other end. You're putting your audio through more stuff, and that stuff can introduce noise. With a graphic equalizer, you have all the filters looking at all the waves at once, and then they put together their own component of that in parallel, right? So all the filters are looking at the wave, they can only hear certain frequencies, and then they'll put it back in all at once. So there's less whisper down the lane with the graphic equalizer. Well, we tried the graphic equalizer. We built this one. So there's a bus line right here that takes your audio out to everybody, right? And so we were able to get the filter running. It wasn't at the same voltage because this is a different project. This one probably expects like 15 volts for everything, whereas we have 10. That's fine though. We have 10 volts for everything. That was enough to power everything. We got it into the filters, and maybe the gains are a little bit weird, so we didn't quite see as much of the filter effect from the graphic equalizer. Yeah, all parallel goes in there. Certain frequencies are then extracted from that, and then they're adjusted and then sent out along with all the other frequencies from all the other filters. Whereas the one that we're going to build today takes all the audio in and then manipulates it and puts it back out for the next filter. So that's what we're dealing with. And I think this one might work a little bit better. I think the parametric EQ might work a little bit better to manipulate the audio. We didn't see much effect from this one, so we're going to try this one. Here's the thing, I don't have dual potentiometers, and those are to adjust what frequency is being looked at. So what we need to do is we need to choose a couple frequencies, depending on how many of these things I can build, and then cater the resistors to those circuits. But we're going to build a module. We're going to build a module out of these to sort of expand on what we learned from building these filters, is that, first of all, building this many repetitious circuits is really annoying. And I think it would be better left to the world of soldering, since most of my parts are surface mount. I don't have that many through-hole things. I don't have that much. So I think it'll be better for us if we build these onto PCBs and then we roll from there. Because I can make this into a module, and then I can make a couple repeat modules. So we'll have two filters per module because it's a dual op amp, and then we can roll from there. And that way I at least keep the number of filters even. I mean, we could do 4, 6 is how many I need. 6 is how many points are in my original adjustment. So if I build 3 of these circuits, we'll have enough filters to fully realize whether or not this thing sounds the same as my mic pack. Does it sound like a deal? I think it does. I got 70 people here, and everybody's weirdly quiet. I'm gonna plug the fart box back in. Now that I'm done explaining what I'm doing, you guys can be irreverent. All right, I'm like super tired today. Recently finished my Pioneer SG95. I don't even know what that is. 5 quad op amp ICs. Nice. 10 band, 2 channels. Damn, dude. Yeah, this kind of stuff is easy to do if you're making a PCB, but if I'm soldering this thing together on Perf Board, it's a little bit more difficult to do, unfortunately. It would have been cool if I had all these ideas like years ago when I built this thing, because like the entire bottom layer of this PCB is like almost completely unutilized. So if I did another 1-layer PCB, I probably could have put all that stuff on here. But anyway, all right, we're gonna need parts. What parts are we gonna need? Jesus Christ. Well, I gotta figure out where I'm building this thing first. So I need a perf board, and then I need probably headers, and then I need op amps. I need to figure out how many op amps I have actually. The ones that we used on this thing are, I tried a bunch of the different op amps, and some of them work just the same as the others, but the one that I ended up using for the old mic pack was this guy. This guy had the best gain out of all of them. They're the best gain out of all of them. Now, I'm not sure if they sound differently necessarily, but this would be the National Semiconductor LF353. It's an old amplifier, but it checks out. It's a really old one. The LF353 is kind of a legendary, not legendary, but it's sort of a staple amplifier. It does the audio stuff well enough for us. So let's see if we can find some LF353s. They're probably in this one. Or not. 34A. Here's the Electron ones. The Electron OP. These are the ones we took out of Julian's synthesizer because he found some forum that replaced them with better op amps. So these are the old Electron op amps. I wonder what these are. Hang on, let's look these up. I'll see what these are, because if I could use them, that would be cool. We replaced his op amps. They're covered in Chipquik, but they still work. What are you? What is? Supposedly the people from Electron were watching the stream too when we were doing it, which is pretty cool. Or it could have been our friend trolling us. It might have been our friend trolling us. Wait, this one's like brand new. I don't think this is one of the ones I removed. Texas Instruments, huh? I should have known. What is this? What is this one? SLK? 40 something something something. Hold on. Damn it! We need to get closer anyway. Let's get closer. Earthquake. Tabernacle. Got it. Okay, what's that number? (48A8) SLK. 48A8 SLK. 4888 SLK. Man, they just used the most confusing. 48A8 SLK. I'm missing a lot in there. Free email service with Jacose. 48A8 SLK. 488 SLK. God damn it. Huh. Whoa, excuse me. (01644A). Remote fit for Samsung. What? TI. No, not TI-84 calculator. 4888 SLK. 4888. It just like wipes everything. 48AL, blah, 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 phase diagram. No. SLK. Can't get that wrong. Looks like there aren't any great matches for you. How is this like a forgotten circuit? Now I know that my moderator wants me to do this, right? Yeah, it's not really working out, is it? Zero 01644A. Let's see. 01644A. Oh my God. How does this not exist? Modular jack. Multiple light beam safety device. Man, all right. Weird. So yeah, I don't know what the hell this thing even is. I'm scared of it now. Let's get one of the other op amps, one of the ones that I clearly removed from the piece of equipment. I'll leave this for another day. It might have to get weird with the searches for that one. I don't understand how there's no information about it whatsoever. This one's seen better days. That's just because I used a lot of stuff on it to get it out of there. Dear God. All right, let me get a cleaner one. Let's get a cleaner one. Maybe it'll actually part. That's the one that we don't know. Hold on. I think they're both covered in stuff. I'm just wondering if these are a usable quad op amp. Because these would be the only quads that I have. Oh my God. Can't see anything. Okay. All right. I don't know what that is. This stuff should just flake off. I can wipe it with a finger and see what it is. I mean, I could just bathe it in acetone too. That'll also get rid of it. These are the original Electron synthesizer op amps, and people on audio forums decided to replace them with more powerful op amps. This is before I had my air soldering station, and when I removed these, it turns out they were glued to the substrate. Oh boy, that was a harrowing experience, because you use chip quick and you expect the chip to just fall out. But I had to actually like physically break these off because of the glue that was used. It was I thought I was breaking Julian's expensive gear. It's always stressful when Julian is like, hey, I need you to modify some of my audio equipment. And I'm like, ooh. This is an LM series. That's good news. It means it might be a rail-to-rail. It might not have the type of performance that we want it to for our specific circuit. Where'd it go? It jumped away. You saw it. Is that LM8 something? Ugh, I can't read it. I can't read it. National Semiconductor. LM837. 83 something. Hold on. If I use a little alcohol on this, I'll be able to see it, but I'm trying to power through because I'm not even sure if we want to use it at this point. Oh, I don't want to bend those pins. Hard to bend surface mount pins, but it can be done. We got to catch the light just right to see these markings. This is sort of the tough thing with working in electronics, is getting just the right light so that you can see what a part number is. I want to say it's an LM343, but nope. LM537M. LM537M. Hillbilly Arm, AK-47. What? Okay. You got a gun. That's not what I'm looking for. Oh dear God, no. Stop. This is no. No, 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 no. Get out of here. Data sheet. Honeywell. Eisner. Is it 537 or it might be 357? 357 sounds more familiar. Let us see. No, it's definitely 537. That's what I searched anyway. I can see the 537 in there. Can you see it? Hold on, let me see if I can get the light on this just right. That's definitely a 5, isn't it? LM, it might be an 8. No, that's a 5. That's a 5 if I've ever seen a 5 before. And I'm pretty sure I have. LM537? 568? Yeah, you might be right about that being a 6. All right, hold on. it keeps jumping when I try to grab it. Trying to grab it so that I can show the part number. These are usually lasered on and they're pretty resilient. They shouldn't come off with a little bit of flux. I think it's the residual stuff that's just not letting us read it. It could be a 557. Oh my God. These would probably be the only quad op amps that I have. I don't know if I have other quad op amps, so that's why I'm stressing this and trying to look it up, because if we can build 4 filters in one circuit, that would be pretty good. I need 6. I mean, I also have a thing that lets me build op amp circuits if I have a quad op amp. All right, let's put a pin in this. Let's stop wasting our time just looking up one number. If we need to, we can come back here. So the one that we're looking for is the one that's already there. The one that I got good performance out of for the microphone, which is this one right here. God, this stuff is huge on the microscope. LF353. We're looking for an LF353 series op amp. I don't know where I don't know what those are. If I have spare op amps sitting around here somewhere. 353 is what we really need. Those are used optical isolators. Fuses. Something. Center. LPF. I don't even know what that is. Miscellaneous desoldered stuff. I do see port expander. Okay, so none of these are going to be it. Put that aside. I have a lot of surface mount parts, so we just got to find the op amps. Now, these are miscellaneous passives. Hold on, let's get those out of the way. Hum, 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 hum. What's this? These are Maxim switching circuits. That's what these are over here. They're like little digital switches. I don't know what that one is. I don't think that's a, well, let's take a look at what it is. These unlabeled bins are not good. I should label everything. I need to sit down and relabel a lot of stuff, and I need to order some parts that I'm like running out of. Let's figure out what this one is. It's probably not anything to do with what we're doing, but it is the right form factor. This one is Micro Semi 24C02C. 24C02C. Datasheet. I2C EEPROM. Don't need that. Hey, you gotta let me look these up, okay? You guys can feed me answers all day, but there's nothing to learn with that, right? You need to see the struggle. You need to see the struggle of what to look up, how to look things up, because not everybody knows exactly how to look up every IC like you guys do. All right, back to the bin. Back to the bin. I got a bunch of miscellaneous stuff in here, but I don't think any of it is an op amp. I don't think any of this is an op amp. There are some chips, but most of this stuff is like leftover SparkFun stuff. Yeah, a lot of crystals in this one. All right, so nothing in there. That's fine. Next. Those are passives. Okay. We haven't even started to dig into my parts supply. Nothing in there. Some electrolytic caps and stuff. All right, next bin. There we are. There's some more stuff in here. These are the tiny fans. Tiny fans that hopefully I don't need for anything. These are chips of some type, but I forget what they were for. Isn't that a kicker when you kind of forget what you bought this stuff for? I know I do have these little tiny op amps, but I don't think the performance of that thing was very good. These are, I think, accelerometers. I think. Or no, some of them are port expanders. Some of them are port expanders that I was going to use on a different project. Of course, I have an air soldering station now, so I could probably do that. I think the op amps that I'm looking for are labeled. There's the fucked AT Tiny's bin. LEDs, some high-rose connectors, a resonator. No, not that one. Tiny fan on an audio output transistor heatsink. Do they generate that much heat? I mean, the mic pack does generate a little bit of heat. I think when we looked at it, the transistors on this thing that are filtering the analog off of the phantom audio, those generate just a little bit of heat. I2C accelerometer. Atmega 328. SO8 op amp that's not even labeled. Tell me this might be a single op amp. What is that one? Let's check it out. Oh, dear God, it's in bad shape. Oh, are these the LF353s? They are. Oh, man, I've got a whole friggin' drawer full of them. Oh, happy day. All right, so we got enough of these. That's perfect. I have an absolute shit ton of these things. Assuming that everything in this bin is an LF353. Can't really be sure about that. But the first thing I picked out was, so I remain hopeful. Yeah, I think they all are LF353s. It's perfect. I think these were being used as instrumentation amplifiers on a different project. So I've got a lot of them. I ordered a lot of parts for that because it was funded by that research operation and not me. So we got a choice here of what I can do. I can try to build these things on little PCBs that sort of meet the needs of dual op amps. They've got some room for extra components. It's not going to be enough to build the whole filter, but if I could use these boards, they would be a little bit more organized. Or, why is that in a different color? What's going on with that? Why is TM? You did something with it is like an actual TM mark. It just shows up weird in Chatterino. Or I can build them on generic perforated prototyping board. Let's take a look at the specific PCBs and see what we can cook up. Let's see if we can figure something out for these. So that would be these. I'm trying to use them up because, you know, like I don't use them a whole lot. These are great for moving your surface mount stuff into a perf board, breadboard application. I literally taught myself to say the wrong one between breadboard and perf board. I literally have just taught myself the opposite. And so now whenever I say it, I'm saying the wrong one. It's obnoxious. It sucks. It really sucks. Don't learn things that I feel like I've been trained wrong as a joke. Okay, We need a surface mount 8, SO8 integrated circuit board. Now, I've got generic ones here in this kit of boards, but these don't have room for any additional electronics. They're blank on the other side. If we look at those on the scope here, you'll see better. If I focus the scope on the actual subject that I'm looking at, you can see that these are like these little clever things. If you're testing out a surface mount chip that you want to put into a design, you can buy little breakout boards for them, and then you can put this into your solderless breadboard, which I can't get a grip on. You can put them in your solderless breadboard and just plug them in, right? You can just try out whatever chip you want to try out. But I want to make a module. I don't want to just use this one chip. Now, I could take 3 of these and build the circuits on the solderless breadboard as we did with the others. I would rather build a module because most of my parts are surface mount, like getting the right resistors and capacitors and stuff. It'll be a lot easier to do if I keep it on like its own little board, and then I can plug the boards in and route them all much more easily. I don't know, it's just the way I'm thinking about doing this. A different method to do the same thing that we did before. So that would mean that these don't work. So my other options, well, I don't have a ton of other options, it looks like. Some of these boards are kind of specialized, and some of them are actually pretty cool. I want to show you guys, there's one in here that is built for a quad op amp. It's actually got all the connections to all the circuits, and I don't know if they're arranged in such a way that I can use them with this filter. I don't think they're quite built exactly for this filter. But like, you know, something like this, I could also drop the chips on. I wouldn't have much room. There's a little bit of room for prototyping. Other ones, like... Why is that one all screwed up? Huh. I'll throw that out. Other ones, like these, have a little bit of this is like... everything's out of focus. Hold on. Have like specific room for prototyping on them. So there's like... You can put your surface mount resistors on these, and then you have to run like jumpers for them, but it kind of helps. You know, decoupling, room for a decoupling capacitor. Some of them are more extensive. They have room for a lot of different stuff. So I could put an SO16 on this, or 2/8, and I could run out to the other parts of the circuit and build various little filters as needed. I never really found a good use for these. That one just has a little bit of extra room for some prototyping. They give you everything you need to be clever. I'm not clever. This one is ridiculous. I don't even know what I'd ever do with this. It's just like a shit ton of connection points. You really got to be in the disposable stuff in order to get these together. The disposable nature of all this stuff. Let's see, what's in here? There's some under this that I think are more complicated, but I can't get to? Can't get my fingers under that. Where's my tweezers? What did I do with the tweezers today? Where are the tweezers today? They're nowhere. They're there. Nope, these are just for large, very large pinout chips. Jeez, not useful. Where was the one that was specifically for prototyping? See, these can take an SO8. I don't have enough of these to build these, but I could put an SO8 on this, and then the other side is all of the, it's just like a prototyping area that I could utilize to put together the remainder of the circuit. I think we're gonna have to freehand these on other prototyping board, because yeah, these are too extensive. They're too specific too in some cases. I'm just looking for the one that was specifically for op amps. I think this one would have been a good one to use. This would have been a good one to use because it's got a lot of room on the bottom for prototyping, but I've only got this one. So if we were doing one filter, yeah, maybe that would be great, but it don't make no sense for me to do it for this. I need three boards. Freebird? Where's the one that was specifically for op amps? There's one that has like specific op amp like circuitry drawn on it. Is it in here? It might be smaller than I thought it was. Wait, is it this one? Nah, like maybe I took it out the other day and didn't put it back properly. That's probably where it went. That's where most stuff like that goes. That's where most stuff like that goes. These are really the valuable ones. The ones that allow me to use surface mount like transistors and plug them into the prototyping board. Oh wait, is this it? No. That's just one that I've used. Nope. Nope, that's one that I've cut. Darn, I thought it was in here. I wanted to show it to you guys. Thought it was in here. Wanted to show it to you guys. But time makes fools of us all. I don't see it. All right. So I don't know where it is. I have one, rest assured. I have one that's specifically for op amps. Wait a minute, is it this one? Yeah, here it is. Here it is. I have two of them? Hey, I got two of them. What if I could use something like this? This one is built specifically for op amp circuits. I don't know if I can use these though. I've got two. They're blank underneath, jeez. Oh, and they fit the entire row of the prototyping board. Huh. I don't know how useful that is. But this is like very specific for all the filters, and it's very specific for a quad op amp. So I can build the filter on, I mean, if I found like the Electron, the quad op, I could build two of the filter circuits on this. But the question is, there's some additional stuff to the filter that I don't think is really represented here. Like the output going there and over there, then there's this. It's like this pin going to here, going to there. What goes to that? It's just a through hole, huh? Yeah, I don't think these will be terribly useful, unfortunately. All right, so we got to invent an LF353 circuit, and then we got to repeat it 3 times in the mirror at midnight. So how much space am I going to need for the circuit? What kind of components are we looking at here? Some people plan out what they're going to build ahead of time. I'm not quite like that. Some people use like circuit design tools to help them plan stuff out. And actually that was originally what I was going to do with the mic circuit, I think. And then it just kind of ballooned into its own thing. Like I was like, well, if I'm doing the schematic, I might as well just build a circuit board and then order the circuit board online. Now this we're just giving a particular type of filter the college try. So what is it, LF353? Wideband JFET op amp. This is what we're looking at inside of that chip. So we've got 2 op amps, and they have power and ground going to them. They have our 10 volts going to them. We have an A and a B circuit. It's like my party game where you have Team A and Team B, and Team B are the winners. All right, so let's see. So our filter's coming in here. We send it through a 10K ohm potentiometer, which I have in droves. I ordered a bunch. I got these guys right here, these instrumentation amplifier, or instrumentation op amps. They're a little bit more stable. So yeah, these are 3-pin. They're kind of big, but each filter will have one of these. KiCad, last time I did a circuit on the perf board. It was a tip I heard from you. Worked out way better than just doing it off the cuff. Huh. Yeah, I tried at one time. I tried to build a circuit in CAD in order to organize it on the board, and I thought that would be super clever. And it is to a degree, but then I just got bored and ordered the circuit board. I just built it into physical hardware instead. I'm like, this effort is just doubled. I'll just build it. So we've got a pretty simple amplifier circuit here with the 2 resistors, one of them going into the inverting amplifier and the other one on that, and then we got the potentiometer doing the offset up here, And that's just all there is. I mean, there's what? 3 resistors there, 3, 4, 2 capacitors, and it's all tiny surface mount stuff. There's not a lot to these circuits. I think we can build some pretty small electronics here in order to make like filter blocks. We'll have power and ground, and then filter in, filter out. That's all she wrote. I don't know about that 100K too. Hey, Coderushed, how you doing, everybody? We got a raid of 6 people coming in from Coderushed. We're getting our ducks in a row right now. We're figuring out, was this an intentional raid this time, or did Coderushed like slip and accidentally raid? Did he threaten you guys with a raid and then try to back out and accidentally hit raid? We're looking at this circuit here because we're going to build this filter. This is a God, that Rabo's emote. I'm always that's my secret. I'm always accidentally raiding. We're looking at the circuit, and this is a parametric EQ. So parameter-ic. It's got parameters. The whole signal is being passed through all of the filters at once, but not in parallel. It's one filter's output goes to the input of the next filter. And so we got to build this. And I'm not going to do the 1N4, 148. So I'm not going to do the overload thing. I don't care about that. So we got to build this, and then we have to alter the components in order to change its frequencies. So C1 and C2, and then VR3B and VR3A are not going to be adjustable because they don't have dual potentiometers. I'm just gonna make it a fixed frequency, and we'll adjust it with values. We'll use science, facts, and logic in order to adjust this thing. Thank you for the raid, by the way, Coderushed. Thank you. Yeah, not a lot of components though. We don't have a ton of stuff going into these, so I think I can make them pretty small. So let's get to work on that. Let's get crack-a-lackin'. So in order to build something with an SO8 IC on it, I like to use this stuff. It's this square perforated prototyping board. So this has square pads on it. This is the old stuff. Where's the newer stuff? I don't know what happened to all of my perf board. I think I need to buy more. This stuff is old. See, this is the stuff that I was using for a long time, but I think I rearranged my desk a little bit, and now I don't know where the rest of it is. But I use this stuff with these little square holes on it, and I think what we can do is here's a piece of it. That should be enough. What we can do is we can put down a little bit of Captain tape, and that will protect the IC from shorting out on the middle pins, and then we can put the extreme pins soldered down to hold it in place. So here's what I'm looking at. I work with a little vise in order to hold stuff in place. We haven't done this in a little while. We haven't had an opportunity to do this in a little bit. Let's see. Let's put on the small tip for the soldering iron. Peter Wolf subbed for 2 months. Hey, man. Hello, Owl Electronic guys. All right, how's it going? How you doing? Thank you for subbing. I really appreciate it, man. Well, you're gonna go on a list of names, and you'll be among us. You'll be among the first to go up on the board in a random order, thanks to your subscription. So when we get that board crack-a-lackin' again, it'll be in rare form, but we'll have a bunch of names that'll go up on it initially. I'm hoping this board will hold a lot of names. I'm hoping. Here's hoping. Can I get a smaller piece of this to start out? I'm trying to like limit myself so that I can actually like make a small circuit out of this without overwhelming. Because if I spread out too much, I'm gonna have trouble fitting them on the prototyping board. On the breadboard, the board of bread. Nah, it doesn't look like it. Well, this is a slightly smaller piece. I guess I could cut. And there are other smaller pieces on here. These are all just scraps. I'm just building this all out of scrap. Scrap material. Gotta use it up. Use it up. All right, let's try it. Let's try to make it a small piece on this, right? Miguel Oz! Miguel Oz, my second ticket to the new board. Hell yeah, dude. Hell yeah, dude. Thank you so much for the 20 months, Miguel. Okay, so we're gonna make a little op-amp circuit. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little surface mount components, and then 2 very large components going onto this. One of them is the IC, and the other one is just, where are my wire cutters? That's what I'm like stalling while I look for them. Where did my wire cutters go? I need them. What did I do with them? They're usually on this desk. Why are they not here? Oh boy. All right, I gotta find these wire cutters. Man, what was I doing with them last? I was stripping wires and stuff. They end up all the way over here. These are, by the way, I've got the parts for another octo pedal that I gotta put together in the near future. I don't think we'll do that on stream. I think I'll just do that on my own. It's a quick job. These wire cutters are my more powerful cutting implements for like chewing up board. Oh, here they are. Why are they in this drawer? They made it into the drawer below where they normally go. All right, so I need to basically make a canvas that I'm going to be putting parts onto. So let's square this thing up, make it nice and clean here. See, these just happen to be a more powerful cutting implement for me. So usually cutting and filing is the way that we get there. So let's take this right here. I think this will be enough room, but we'll see. And then I gotta repeat this a couple times once I figure out where everything's going. So I'm gonna take a metal file to this. If I can find it, it's not where it normally goes. Where's my metal file? God damn it. All right, perfect. I don't know where my metal file is. I don't know what happened to it. I'm gonna look for it over here, but maybe just walking around will reveal. Did it slide under a little bit? Nope, I don't see it there. I feel like I remember putting it somewhere and being like, I'm never gonna find this again. That sometimes happens. That sometimes happens. Usually I use it to like deburr stuff. I don't usually put it on like a magnet hanger because it's a friggin' file, you know? You put it up above, no. Usually it sits right there. Not putting it right there was my first mistake. Unless I like threw it and it flew under here too far. I don't see it. I don't see it. Ooh, finger cramp. Why did I get a finger cramp? That's an odd one. I don't see no file. Why don't I see my file? It's supposed to be right here. Did I use it at another desk? That's usually my downfall. I think I had it over here. I was filing something with it. I think when we were working with metal the other day, we were looking at what? Laser stuff? It didn't end up. And I don't think I brushed it to the side. Unless... No, it's not here. Son of a bitch. What did I do with the file? Well, it was getting to be about time to order another one because they dull and they're not expensive. Did I put it all the way over on the magnet hanger for no reason? Looking at the magnet hanger, I see all kinds of goodies. No metal file, though. Well, this is going to be a mystery for some time. It's not the kind of mystery that I like, though. Not the kind of mystery that I'm raring to solve. What's under here? Not under that. Up and around. Up and over. Under. Through. Nothing. I see nothing. It's not sitting right in front of my face, right? No, that's a ruler. All right, I don't know where my file is, so I guess I can't clean these up the way that I wanted to. Which is okay. It's not like we need to. It just makes it a little bit more fun to work with, and it's less, it doesn't like scrape you on the floor. Not on the floor. Let's see, behind stuff, on the magnets by accident, no. Weird, I usually just keep it around that area. No luck. Hey! English, please. Did you open the folder? It's a joker over here. Look out. We got a funny one. Boy, oh boy. Raring to go. He's got all the jokes lined up. Got a funny boy over here. All right, so I don't have anything to clean this up. Usually I'll like rub it on a file a little bit, and that'll clean up the edges, but we'll just work with rough edges, which means my vise might not hold on to it quite as well. But that's all right. We can continue on. It's just my curiosity now has me looking everywhere for this, for my metal file, which typically hangs out in one place, and when something's out of place, then I don't know where else to look for it. Yeah, that's weird. I wonder what I did with it. I wonder what I did with it. I probably thought I was very smart moving it to a new location. Very, very smart. All right, so we got a couple decisions to make here with this board. Got a couple little decisions here. Those decisions are how many pins are going into this thing, and where are we, you know, attaching everything. We have a surface mount, an 8-pin surface mount chip that has to go onto this. And I had one sitting, yeah, here it is. I got one of them right here. So this is our 8-pin surface mount chip that has to go on this board. Let's pull that up on here with the thermals and everything. We can see. You guys hear the fan at all? Hopefully you can't hear the fan. I need to move this up like that. You guys are going to have a little bit of parallax. A little bit of parallax, but it should be all right. Brighten you guys up? I can't. That's maximum over brightness. All right. So we got our 353. What we need to do is we need to position this on the board so that I can build 2 audio filters around it. The way that I'm going to do that, well, I'll position it on in the long axis. So we should be working on it like this, so that we have a little bit more room on the outset of those filters. I'll just build 2 of these circuits into this. And so the way that I position it, now it's going to be uneven, isn't it? Is that going to trigger everybody? It's going to trigger me. I'll put a piece of Kapton tape on these pins here. So I need to put Kapton under this, I need to put it under this, and then I can solder the 4 corners, and we can work on the circuit from there. And then I'll have a little bit of room over here to build up the rest of the filter, because there's 1 op amp per side, and then we just build up that filter, and I don't need to connect one filter to the other. We can leave that to the circuit. So I can have a common power in, a common ground in, filter out, and I'll have 1 on each side. So 1, 2, 3, 4. I need 6 pins. We're gonna need to spread that out a little bit, just so that we can have both sides of this thing plug into the board. And I'll try to make it big so that it's nice and clear and easy to see. And then I'm gonna have to put 2 of these guys on it, which will take up a shitload of space. Oh boy, that's gonna get a little bit more difficult, isn't it? That's actually gonna be the hardest part of this, is having 2 of these adjustments sitting on this thing. Where's it? Let me get another one of them. I mean, I could like make that part external, but yikes. That is not a lot of space. That is not a lot of space, huh? And actually, the other side of this board is completely blank, so those are going to be very difficult to attach. The alternative is that I break that part off of the, like, have this on the board. Like, if I do that on the PCB, then what do? I have 1 input here, center tap, output. Input, center tap, output. Should we do it that way? Because that way I can split the adjustment off of the board. What's up, Jeebus? How you doing? I split it up like that, I can have the PCB with a chip on it, and then it'll be lighter, it'll have less components, and then I have the external adjuster, which is just hooked up to in-out, and all we need to do is add the center pin. So that gives us 6 pins for this thing. Actually, it's really just, it's not that many, is it? It's not that many, is it? Yeah, because we'd have in-out, and then center tap, and then power. So 5, 8 pins, and these are even shared. But I guess we'd isolate the circuits, so this would be its own thing, right? So that's all we have to worry about. I guess that's how I want to do it. So I don't have to worry about these things sticking out of it. So let's make those external so that they plug into the perf board sort of in line with everything, and we know what we're, you know, which one we're adjusting and everything like that. I guess. I don't like it, but you know, these aren't small. Those are going to be a major consideration when I actually build the PCB. But when I build the PCB, I'm going to use the type that lay down, and that way I have 6 of these, and I should be able to fit all 6 of them inside of the mic pack with the circuit boards. I might have to do 2 different circuit boards in order to do the amplifier and the EQ. And if I add a compressor, that's going to be another one. It's going to be a challenge, and that's what I'm kind of looking forward to, actually. Because we'll use Fusion 360, and I'll have 3D models of all the parts. But yeah, right now we're trying out circuits to figure out what works. So I need to figure out how I'm building this circuit and then put it together. I just need to actually commit. So, all right, here's what we're going to do. We're going to do it without the filters on there, and so I'm going to have inputs and outputs maybe, or just like an in and out on one side and an in and out on the other side. And there's 6 pins total for the whole thing. I could literally have this thing be a stand-up circuit board on the thing, but I want it to lay flat so that it, you know, it resembles what it's actually doing. So yeah, let's get some Captain tape down on this thing, and I'll just have to commit this to a location. I could do it up and down like this. There is no middle to this, is there? There's no middle to this board. Oh, what an irritating number of holes I've left. That's okay, though. We'll get around it. All right, so let's just put this thing down. So let me get Captain tape, which is always within reach. Kapton tape is a product what can resist the heat of soldering, and it does not leave a residue. It's like very commonly used in electronics and reworking and stuff like that. You can use it to some great effect for a variety of different things. If you look at pictures of the Mars probe, any of them, you'll see this stuff all over it. They use it in the wiring looms because it's light and it is resilient to large temperature fluctuations. So do some of that. Chippercorn, sub to the Prime for 21 months. Damn, dude. Hey, Mellowfire. 21 months. Insanity. Thank you. I really appreciate that. What's going to happen is your name goes through like 20 computers a day. No, your name is going to go into a list, and we're going to use that list in order to populate the board, the new board, when I'm done making it. You know, I still got a lot of work to do on that board, but when we're done burn the subs back up, you're going to be one of the names that initially gets burnt to it. But it'll be in a random order. Mellowfire, thanks for the follow. It'll be in a random order so that there's no struggle to be the first person on the board. You'll just be one of the names. Those that don't know, because it's been down for a little while, this channel has a gimmick. I am a gimmick streamer. Which kind of sucks. Cannibal cheese. Kind of sucks being a gimmick streamer. you imagine if like Tomato like got to like 6,000 viewers a stream by just like having a fart box? It's like I don't know what the ceiling is or the floor is on gimmicks. Oops, that's the wrong focus button. But like this is my gimmick right here, not the 3D printer, the board on the wall, because that board on the wall gets surrounded by a laser gantry. We've created quite a bit of Python code. That's not what we're looking at right now. We've created quite a bit of Python code in order to run that board on a Raspberry Pi. My gimmick is the shop, I guess. But I mean, like, if you sub to this channel, your name goes into the Raspberry Pi using the Twitch API. It gets turned into G-code that gets streamed out to the laser burner. And so your name ends up on a block of wood on my wall in a random location. It's any consolation. I'm not here for gimmickry. I don't believe you. I don't believe you. That's just right there. See that? Lies. Lies. Why would you lie? Anyway, so the board on the wall. Sorry, I'm like tired today, so I'm like, oh yeah, I'm streaming. I need to actually like act out and be sociable. The board on the wall is this button. There it is. The board on the wall is changing. I decided not to just like put another plank of wood on there. We had 5,500 names on the previous board. It took 2.6 years to fill. This one is going to be a little different. And so what we're going to do is we're going to make one font size for all subs. So I don't have to keep explaining that over and over fucking again. I had to explain it like every day. How are the fonts sized? You can't donate more in order to get a larger name on the board. And now we're going to make that clear. There's going to be one name size on the board. One name size. However, gift subs are going to be a smaller size. They're going to be a different font. So I guess I'm going to have to answer how people get different fonts from now on. Because if you sub yourself, you will end up in a bubble letter name. If you gift a sub to somebody, they will end up in a single line font. This is a live edge board. So I need to map out the edges of the board. Now, I've taken way too long with hardware. We're like way over schedule with hardware. Listen, I'm a streamer, right? I'm in this nebulous fucktown of nothing having to be done, right? What is that? 72 point. Why is it doing the @ command on there? Oh, that's a weird one. That's a new command. And how come anybody could do that? Anyway, I'm in this nebulous fucktown of do whatever you want on camera. And selecting my font size? I don't think so. Anyway, so yeah, this like there are no set schedules or goals or anything like that that I need to adhere to. But in the sort of in the business of streaming, I need to get this done. We're way over schedule for me having the hardware done because we need to be working in Python by now. I need to be coming up with my little application that's going to allow me to use a game controller to move the laser around and map the edges of the board, and then, you know, almost instantly after that, everything will be fine. But oh my God, 3 Mares property is now a bog. Oh my God, to a hydrant no less. Oh my God. Do a custom overlay for the BTS camera that explains the fonts? No, it's simple. It's simple. We kill the Batman. It's simple. Regular subs, big letters. Gift subs, single line. Well, the longer I take, the longer the list is going to be going into it. So we need to focus on it. We will get back. What do you want? Yeah, there's all that sugar. Did you guys know that sushi rice has sugar in it? I do. I feel it. I feel it. And I've still got 12 units on board. So that's going to coast downwards as I stream. So I got to be careful about that. And I've yet to pause a stream because of glucose levels. I've done it like once in 5-6 years of streaming. All right. So What are you talking about? Anyway, we got to get back to burn the subs. We're gonna work on the hardware on Thursday. I'm hoping we get it done because I want to get that together. I want to start working with that more, right? Are you an Android? I guess. I don't dream of electric sheep. All right, anyway, getting back to this. We got to fit this SO8 chip onto this board. So basically what I need is this and this block masked. Did my tip break off? It did. New blade. New blade, who dis? Let's swap them out. These are so cheap. It's beautiful. Get a scalpel. Don't get an X-Acto knife. X-Acto knives suck. Their way of fastening the blade onto the knife constantly loosens. If you get a scalpel, you can get non-sterile blades for it really, really cheap. I'm never consistent about eating small meals, so I always end up hypoglycemic. You actually have an overactive pancreas? Or do you actually have like diabetes like I do? See, I got type 1 diabetes, so all bets are off. I can eat whatever I want, which has really worked out great for me. I gotta cut the fat, man. I gotta cut the fat. Well, cut the fat off of my body. That means cutting carbs. You know, hey, I ate sushi for lunch. That was a bad idea. It's very carby stuff. So all we need to cover, look at this glorious new tip. Yeah, beautiful. Anyway, all I need is this one and this one covered. So I can just cut across this here. Careful, new. Boy, I cut into it a little bit. It's so sharp. This one and this one. Unfortunately, I've got an uneven number of holes on the top and the bottom, but whatever. Yeah, made in England. I didn't check. Look, I bought it off of Amazon, all right? I love these, though, man. The 10A or whatever the hell these are on the scalpel, the stainless steel scalpel holder. It's just a very simple pen knife. The X-Acto blades would constantly loosen themselves, and I'd have to keep tightening it. Come on. These are not as good at gripping tape. Grippy tape. So all I need to do is cover those two holes, and now I can put an IC down on this thing. IC. Ta-da! Man, it is tempting to just spend $5 to build a PCB for these. Just build a PCB, and then I can just add the parts on. That would delay the audio EQ project quite a bit, though. All right, so let's bring some more cameras into the equation here. Chat is still here, they're just much smaller. So what I'm gonna do is just put down an anchor pin. So all I need is something like right there, and I can just bloop, just do that. And then I can take my IC. Oops, go. Where did it go? Okay. I can take my IC, I can just scooch it up to the anchor pin and make sure that these are over nothing. So it's not very organized, not very neat looking. I don't know what's up with these surface mount ICs, they're like dirty. Yeah, that's just going to hold it in place for me so I can solder all the other legs. The other 4 legs, and then those 2 in the middle will be... I'll be able to run wire to them. I don't have a lot of room to work here, do I? I'll have to see how this turns out. I might have bitten off a little bit more than I can chew with this. I'll just add a little bit there to make it look nice. Oh, come on, go over the hole. Too good for your hole. So yeah, this is how I do SO8 on a perforated prototyping board. And the way we add the pin headers is by actually plugging in headers into the solderless breadboard and then soldering them up onto this board. That keeps the pins from the plastic between the pins from melting. See, I do that to make it nice and clean. I just put enough solder on there to bridge the gap. Okay, so that's that. So I need to decide where I want the pins. I mean, putting them across like this would probably be disastrous, so I guess I'm going to go over here. It's partially leaded solder. But it's funny because I'll have a row of pins here and then no room to put any of the ICs. Lead-free solder is fine. I don't understand. Everybody hates it so much. You shouldn't hate lead-free. Limiting your exposure to lead is good. You know, everybody, it doesn't flow right and blah, 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 blah. Turn your iron up. Stop being a pansy. Make your iron hotter. That'll help you do stuff better with lead-free solder. They've messed with the formulation by now to the degree where it works fine. All right, so what am I using to do all the little interconnections? Well, I have this wire wrapping wire. Yeah, everybody's sitting out here like fucking eating lead, huffing the fumes, and like they're like snorting lead powder, like yeah, blah, blah, blah. Now, come on, like limit your exposure to lead. You deserve better than early onset kidney failure. Anyway, right here, this is wire wrap wire. It's solid core, 30 gauge wire wrap wire. It is perfect for making the little interconnections on this board. Love to be at the debate between O'Bother and Big Clyde about lead solder. Yeah. I just said 30 gauge. 30 gauge. 30. 30. It's not 22, it's 30. Smaller than 22. But it's solid core wire wrap wire. Now, this stuff is not really meant to be soldered around, so the jacket on these wires will turn into soup. But when I'm doing the interconnections of the board, I'll try not to actually use the jacketed wire, but what I do is I kind of like sew it. I go down to the layer below and pop up elsewhere. We don't have a lot of room to work here, so I'm going to have to get kind of clever with this. We could try to plan it out, but I don't know to what end. All right, so my connections are as follows. So I got power going in, ground going in. Then I've got 1, 2, 3, 4, 5 components in a row. Oh boy, I don't think I'm gonna do very well with this. 5 components in a row. I mean, even if I put them down along the bottom, I don't think I'm gonna have enough room. It's like 1, 2, 3, 4, 5. That's like one circuit. Yeah, I think we're gonna have to move this to a larger board. I'm gonna need a larger board for this, unfortunately. Even if I designed this like as a PCB, I would have to use 2 layers in order to get all those components on there. I mean, once I get down to 5, there's not too much else to it, but I am just gonna need more room to work. So let's transfer this over to a larger board. Let's transfer this over to a larger board. Where are my boards? Well, this is too large. I need some limitation to figure out what I'm actually going to be building, but if I do it long ways, or if I do it crossways, or if I build... What if I build all of them into one board and just plug it in to the input and the output? That would be 3 of these, and I need to figure out where all the components go. I was hoping to build a module that just plugs into this thing a couple times, right? I'm just debating on where I'm going to be putting stuff. Let's restrict this, and then let's put the chip down in the middle. Now let's figure out what the size is going to be, right? As long as you can on a big board, then cut it off. Well, that's what I was thinking, but I could also maybe put, if all those components are in a row, I could stand up the resistors. Nah, it's probably a bad idea to do it that way, huh? I'm just thinking about, like, I got so many components on there. But it's like all the components are in a line. That's the weird part about this. and I can do the 10 components like that. But there are taps in the mid sections of those components. And then I have to select whatever resistor value I have on that. I'm just thinking about what I'm going to do here. Hold on. Yeah, those inline components are really weird. So we got our input from one pin, then we go into a capacitor, then a resistor, then another resistor. That could become one resistor, by the way. Although I'll probably build it with the individual components, because like in the final design, R2 and VR3, that's one resistor. That's just the product of these two. And then this one's just the product of these two. So they both have a 10K ohm resistor added to them, which is silly. But if we want to actually use his values in the table, we could use his values in the table and add 10K to it. We just have to remember to do that, which I'm not going to. But it's capacitor, resistor, center tap, resistor, ground, and then 22 to ground. And then that one goes into the positive, 2.7, 2.7. Ay. Okay. All right. It's not so bad, actually. I'm going to be able to swing that. So if we do swing that, how would we do that? Let me think about this here for a second. So we would have power going to, I don't know, whatever closer pin that it has. This is the output of one of the filters, and then I think it's plus minus. And so the input would come in, go through 22 NF, one resistor, two resistor, ground, and then a capacitor across that. And then I would need the filter, and then, yeah, all right, let's make it a little larger. Let's make it a little larger. I'm just going to work on a larger board, and we'll see. We'll see where we get to. Let's see what other scraps I got sitting around here. What other scraps do I have that I could work on? I could work on this filthy board. We could just clean it off. That's the same exact size. God damn it. It's the exact same size. It's the same size. It's the same size. Damn it. I am trying to limit myself because it'll make my circuit better as a result. Because the smaller I make this, the better it fits on everything else. Use one of the ones with the, wait a minute. Wait a minute. If these are all surface mount components, wait a minute. Where did the bin go full of the boards? Is it buried? The bin board is buried. I think I can build this on one of the green ones, one of the green circuit board things. Oh, there it is. It's way over here. Because if it's a bunch of surface mount components, I might be able to fit it underneath without too much of a struggle. And that way I can just repeat the thing over and over again. So this one here has the SO8 on top, and it's got the decoupling capacitor on it, which this circuit doesn't need, it doesn't use. But it's got all this stuff underneath, and that's a lot of space for me to put stuff in. So let's try that. Let's try that and see what we can build. We'll have to put two on this. I could see that working, maybe. You guys see that working? This is tough. I'm just like, I'm trying to do this like elegantly, you know? In 1, 2, 3 goes there, and that's capacitor, resistors, resistor. If we incorporate the 10Ks in there, and ground. So between power and ground, I could put two parallels, or between input and ground. So each input gets 3 components on it. So if I have the input and the output, I have the input and that goes to something else. But then that leg of the input, no, that's the center tap of the, okay. Yeah, I think I can do this. All right, let's figure this out then. The only problem is these pins I'd have to cut off in some cases because they go to the taps to the SO8, which it's fine. We can handle that. Okay. Let's try to use this. I think this will work. I think this will actually work. Wait, how many? Okay, I have power and ground, and then the others are going to have to go. I'm going to have to cut that and then route it around to the other side of the board, which is totally doable. All right, so let's cut some traces here. Well, I guess I can desolder the other one for. Well, I have enough of these things that I'll just put a new one down. I'll just put a new one down for now, and I'll recuperate that other one later. Because that will do it. Because this way it'll look like one singular thing, and I can repeat the structures on it easily. You guys think about that. I think that's a better plan. Plus, I'll use up some of these things. Okay, so that's been fastened down. I'm going to get an LF353. Where did I put the binge of them? Oh, yeah, it's SO8 op amp. I didn't even label that one properly. I think this is the one. I think I spilled coffee on these bins. Some of these are kind of gross. That one's actually beautiful. Look at it. It's beautiful. All right, so we'll put this thing down. Put pin 1 to pin 1. We got to work within that structure. Pin 1 to pin 1, and then our power and ground pins are already decided. And then we cut off the other ones. We cut these down here and up here. We can leave some of them intact because our output is going to pin 1. Our input has to go through a resistor. And we're going to do input and output through header pins on these. So we'll have to cut the inputs, but we can leave the output because that's going to be the output from everything. All right, I think I got a plan here, chat. I think I know what I'm going to do. I think I got a plan. Oh, that can fit over top of the circuit without disturbing it. That's nice. All my wires. Here, I'm going to move you guys in a little bit so you get a better view of what I'm doing on the side cams. Get the knife. Every time I have the knife sitting on the desk, I'm always afraid that I'm going to put my wrist down somewhere and just like slice my hand open. And then I'll be like, don't worry about it, chat, while I'm like bleeding out on camera, which is technically against TOS. But I don't think anybody's reported me for it in the past because that's kind of like a 1-2. It's like I've accidentally cut myself pretty badly and my channel gets taken down. Like, that's not cool. I could drag solder these if I put on a different tip to the iron. Drag soldering is when you have a very large soldering iron tip, you load it up with solder, and then you just go right across these, and they all solder themselves, and they're very beautiful looking after you're done. I'm not going to do that. I'll just add some solder to the thing, and that'll be that. Now, I've seen people put resistors across these pins before, which we might do. For instance, like if we have the feedback resistor in... I forget if it's inverting or non-inverting. We might just put the resistor onto these long traces, these long tracts, these huge tracts of land that they give you for these things. If I were a real crazy person, I could use hot air in order to stabilize this and make it look nice, but I'm not going to do that. All right, so in the grand scheme, we've got a lot of room to prototype on this thing. We're not going to be able to fit the potentiometer. That's fine. What we can fit, here, I'll be more animated as I talk about stuff. What we can fit over here is all of the, sorry, I tend to be too static on camera, and so I'm like, I try to move around a little bit more. And so I was just exaggerating what I thought I should do. So yeah, anyway, pins, and I believe this has the same pin out. Pin 1, 2, and 3, like that. Let's check with the data sheet real quick. Pin 1, 2, and 3. Output A, blah, 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 blah. Output B is pin 7. Pin 7. So yeah, the pin numbers are good. So we're basically building this, except we're using, we're having outputs. We'll have an output here that's separate from the input here. Just because. All right. So yeah, our input over here needs to go through a resistor to pin 2. Pin 2 and 1 are connected by a resistor. Pin 3 goes out to other circuity kind of stuff. We need a pin for the capacitor here. Unfortunately, we might be breaking pin 3 and moving it to the underside of the board. Because pin 2 gets a resistor and then goes to the output. Might have to break pin 2 and put it through a resistor. Yeah, that's what's going to have to happen. So we got our output here as pin 1. Pin 1 and pin 7 are unaltered. Pin 3 gets cut. Pin 2 gets cut because we can't use it outside the board. And then we have a center tap pin and an input pin out of pin 2 and 3. Yep, that's the plan. Power in, 1, 2, 3. Other side, ground in, pin 1, 2, 3. We'll have exactly enough pins. Man, this is going to be good. This will be good. Let me focus the arm. Spring arm's like way out of focus. There you go. All right. So pin 1 is the output from filter 1. Pin 2 and 3 get cut. Now, I have had times where I have shown you guys the way that I cut with a knife. What I would do with the pen knife, or the scalpel in this case, is just make 2 cuts before, well, 2 cuts in that, and then I'd peel up all the copper material in between. But I bought this thing. This is a tile cutter. This is for making like printing press tiles, like linoleum tiles that you cut little troughs in, and then you can put them through like a roller in order to make a nice little pressing. We did that in high school. It was fun. But yeah, that's what this is for. And so what this allows me to have is this little tiny trough cutter. So what I'm going to do is just run that across here, and then pin 2 and 3 will now be severed from these 2 pins. Because remember, one of those is our output and the others are input. Or no, one of them is this is our output. We'll do output, center tap, input. All I need to do is just go like this. Yeah. And unfortunately, that doesn't cut it in one swoop. I'll have to come back and do it again. And again, and again, and again, until I finally actually cut into the substrate and sever those traces. So there it is. That's our, I think that's cut. I'm not too confident. Hold on. There we go. Those 2 traces are no longer running to the outputs. We'll do the same thing over here, except the pinout changes on this side. It actually moves to a different location. So now we're doing it to pins 5 and 6. So 1, 2, 3, 4, 5, and 6. These 2 pins here. So it goes non-inverting, inverting, output of the op amp, and then power or ground. I forget which one that is. This one is power or ground. I forget which one this is. I think this one's ground and this one's power. And then your op amps are across these. So we're cutting these 2 now. I don't want to overdo it and cut the wrong thing. I'm hitting the trace right now. Ugh. I got close. I got real close. I think the knife is a little bit more controllable, but this thing is cleaner. I cut from the other direction. I just saved myself from myself and just cut in the other direction. I can use some of the wider tips to do this, but I found this tool to be to make a nicer cut across the trace and make a nice severance of the traces without too much hullabaloo. I've put 3 lines in it now. When is enough going to be enough? I don't want to do any more because I've already scratched that. Ugh, maybe that was the wrong tool for this job. I could just do this. Just run the knife right here. Just to be sure. Nuke it from orbit. I don't think there's any copper left in there. All right, so those are severed. So there's no more connection there. I will have to run a wire around the side of this thing in order to get to it. Now, if I really want to, I could also put a decoupling capacitor on this, but this schematic doesn't have one. There might need to be one, but I'm not totally sure about that. So I'm just going to live and let live on that in that instance. But yeah, I will need to run those to the other side of the board. Now we have our output, center tap, input. So output, center tap, input. I'm going to make sure that those are in the right spot. But our output being right there, actually, wait, where does the feedback resistor go? It goes to the negative, right? So pin 1 and 2 will get a resistor in between them. I just double check on that, on the positives and negatives there. Pin 2 is the inverting input. Yeah, okay, cool. So yeah, the pinout matches, which is helpful. It's actually very helpful. A 2.7 kilo ohm resistor. Let me get a 2.7 kilo ohm resistor. Where's my mouse? There you go. 2.7K. Let me make sure I didn't pull it out already. Pull it out like all my hair. 2.7K. These are mega ohms. These are capacitors. I'm going to need those later. These are ohms. Those go up to 820. That's not the right one. I'll put these back. We'll have to add 10K to both of the values so that we're putting fewer components down, just so that I can actually work within this this small prototyping board. 2.7. Well, this starts at 36K, and if you'll notice, I put some dry erase marker dots on the various values of these things because some of them were mislabeled and I don't have any of those particular resistors. Really annoying. I did order 1Ks. I didn't order any of the others, though. 2.7 right here. Pay dirt. All right, let's get these out, and let's get these into the circuit. Let's get these into the circuit. So I need 2 of them. One of them is going to go between pins 2 and 3, and the other is going to go... I mean, I'm going to need more 2.7Ks in the future, but let's just start with one. Let's just start with a feedback resistor that goes between the inverting input and the output of the op amp. And that's going to be 2.7K, which I don't know why he chose this particular value. I guess it has to do with the gain that he wanted to achieve. But what that means is that we can put a resistor here between these 2 pins. And this is an 0805. It might be a little big for this, but I can just kind of work that like that. And I can do the same thing up here for the other side, and that'll start our circuit off. So I should probably remove a little bit of solder from this in order to get that in there. It's just kind of a little tough to... The 0805s are a little tough to put in there. If I had 0603s, they'd bridge it nicely. It's not as quick when you're building a circuit and trying to teach as you go. All right, let's work that in there. It didn't even try. You're not even trying. Come on, man. Do this. Yeah, for some reason my solder isn't like flowing over this stuff. Usually an issue of flux, but I'm not going to add flux. I got rosin core solder. I'll just do this. Bloop. See that? Instantly flows. Instantly flows. Even flow. Okay, why is this happening so sloppily? Man, my tinnitus is going nuts. You know, it's not an itis, so tinnitus isn't correct. Tinnitus. Well, I think that's soldered. It's just like kind of doing weird stuff with the surface tension. So we'll do the same on the other side, and hopefully it'll turn out a little bit more neatly. That doesn't need to be neat. It needs to work. I guess it does need to be neat because we need to be able to actually like We need to actually be able to like work on this thing and see what the values are and change the values around if we need to. The other side of the board should have everything nice and organized though. Let's flip this. This is still out of focus, isn't it? It's a little better. It's hard. The focal distance with this camera is very... It's out of... Why is it out of focus again? I feel like I need more glasses over my glasses. Crisp, clear, in focus. All right, good. All right, so this one goes between these two. I can get them both to flow over at the same time. It's just whether or not the solder will run up onto the resistor. It probably won't. I'll need to get close here. And then once I dab, you dab? Dab? Okay, it dabbed, but it went under. I actually think that is making contact. That one went in way cleaner than the other one. Holy crap. That one went in like textbook. Jeez. Maybe we can clean this one up. The other one set my standards too high. We'll flip the tweezers maneuver. So like, why is that one doing that? Could you maybe just like cooperate and do an even amount of surface tension on both of these and maybe not be all crooked and shit? Whatever, it's close enough. I'm gonna use a little desolder braid to get rid of that excess. Desolder braid is as close to visual asthma as this channel will get. Good enough for me to poop on, I guess. Man, I really want to like straighten that out. Okay, that actually did it for me. It's still making good contact. All right, good. So there's our 2.7K feedback resistors. Now we have another 2.7K on this filter. And that goes to more stuff. So we did this right there. What else? Let's see. Well, we're going to need to get pin 2 down to the other layer of the board. And it looks like pin 3 goes through the resistor complex. That doesn't actually connect. All right. So the output goes through a 2.7K to the junction with the pin. We don't have that kind of command. When applying that much heat onto resistors, does it not damage or alter its characteristics? With the amount of heat that I'm using, no. It doesn't do anything to the resistor. The resistor cools down afterwards. If you look at the back of a data sheet, not the back of a data sheet, look at the very bottom of the data sheet, it will tell you what the heat tolerance is of it. And when general like soldering, you're not gonna hurt a resistor that way. Some older electronics are more sensitive to heat. You got to be careful about soldering them. The biggest thing that you can do when applying too much heat for too long, don't listen to the people in chat. They have no fucking idea what they're talking about, even though they're textbook repeating people. With older ICs, you can damage them. The main thing that you're trying not to apply heat to for a long time is, yeah, but that's totally pointless advice that you've given there. The main thing that you're worried about when soldering is applying too much heat to a surface mount pad that doesn't have a via in it. The via is the thing that goes through the board. If you apply too much heat to a surface mount pad for too long, it will delaminate itself from the circuit board substrate, and then you've got this like floating piece of metal that you need to solder to a thing, and it can break off, which is real bad. You can supplement that with wires and stuff, and if your PCB is designed properly, that shouldn't happen. And if your iron is at the right temperature, that shouldn't happen. But with my iron at 650 degrees, I'm okay. I'm not really going to burn anything up, and I'm not using older ICs. The resistors and the passive components and the capacitors and things like that, they'll be fine. You don't have to worry about that. But you know, heat's a thing. Heat's a thing sometimes. It's not worth worrying about though in the context of what we're doing right now. So, all right. What am I doing? Input 2.7 kilo ohm resistor, and then to the inverting junction on pin 2. So 2.7 kilo ohm resistor would go from the input to here. Well, look at that. I probably shouldn't have cut that so far out. If I put a resistor here, I could run a little piece of wire between these. It looks like I don't want to populate these pins yet. I don't want to populate these pins yet because they're going to be obnoxious when I work down here. Yeah, I explained it like 3 times already, man. Sorry. Yeah, I don't want to mess things up down here. Plus, I need this junction to do a 10K to ground. Actually, this goes, it also has a 10K ohm resistor and goes to ground. I could maybe do that out here because I think this one is ground. If that's ground, that goes there. I put a 10K out like this. I can put a wire over to here. Man, this is actually becoming a lot more compact. Bist V, thank you for following. Let's get a 10K ohm resistor and let's run that over to ground. Because if ground is here, I can put a 10K right here for this circuit. No, wait, that's the output. I could stand one up here. The problem is it's 10K and another 2.7. 2.7 to output, 2.7 from input. I mean, I could just do it on the other side of the board too. But if I want this to be compact, I can do it here. I can do it right here. I can put the other parts of the filter on the other side. Let's get the 10Ks out. I've got them in a separate bin. 10K. That would be in a different bin because they're, when I work with digital electronics and the surface mount stuff, God, is it so much easier than this. We're doing analog electronics, which is a different animal. I mean, everything boils down into analog electronics, right? But when I'm working with like accelerometers and stuff like that, you just drop down, you just pepper these things down. That was one joke that was stolen by Brian Locke from me, which is when I was talking about being like the sprinkling magic meme or whatever, when you're putting those filter capacitors onto your digital circuits. He took my joke. He stole it. We're gonna need a bunch of 10Ks in the circuit, so I'm just gonna put a pile of them over there. We'll come back to those. There's like 10Ks all over this thing. Although actually, if I roll these resistors together, we won't need the 10Ks. I don't want to have to do that, so it'd be nice if we could build as much of the circuit on the top layer as possible. Yeah, stealing my jokes. Bother will remember this. So from that 2.7K, I have a 10K that goes to ground. From here to ground. How the hell do I do that? Hey, Proteus. I mean, I guess, you know, if I run ground over here, then I can do that. That's just weird. From the non-inverting, that'll have to jump to the other side of the board. So I could do it here. What were the connections for these? Hold on, wait. I need to reference this real quick. Where is the board of boards? Let's see if I can find another one of these things. I don't know how many of these I have, which is a problem too, in and of itself. There's only so many of them left. I've used them for other stuff. Don't tell me that was the last one. I'm gonna be really miffed if that's the case. I had a little shit fit if that's the last one of those. It might be. It might be, in which case all the work that I'm doing here to figure out how to put this thing together is kind of pointless. Oh, tell me I have another one of these, please. Please. I have a larger version of it. I mean, could this whole circuit just be built on this? If I do... No, because I can't do 2 8-pins on it. Because that already has like all the capacitors and resistor placements and stuff. Although there's nothing on the other side. No, maybe not. All right, hold on. I'm looking for another one of those to see how those traces come out under the chip. I'm having a little mental breakdown. I do this every time we do one of these. I have a little breakdown, and then, you know, I figure out where stuff needs to go, and then I'll hunker down and figure out that I've run out of stuff. But I guess we can build 2 filters and figure out how that works if we get through this today. I don't see any more of those boards. Don't fucking tell me that this is the last one. Okay, it is. I think it is. I think it's the last one. I think it's the last one. This is the last one. This is the last one of those. I don't need more. Wait, what about these? Nope. 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 I don't got any more of them. I can't believe that. That's so obnoxious. You would think, and you'd be wrong, that I could use this to somehow build this circuit. But no. But no. Ugh. This perturbs me. This perturbs me. Well, we've already made cuts of this board, so we're not going back. It's the only one of those that I have left. I thought I had 2. I need 3 in order to build all 6 of my filters. And the other option is using something like this, but this is the only one of these that I have. Use something like this, and then I've got all my cuts and stuff that I'd need to make in order to build the board. How many of these do I have? I got 2. I could build 4 filters out of these. You would be wrong. I am incapable of thought. This shit always happens around here. Ah, it's too bad I broke another one because I got a 3rd, but it's all broken up. It's all broken up. That might be the better platform to build this on, to be honest. Although I can't do the stacks of components with this. Is this one-sided? One-sided. Yeah, what would be my motivation here? Well, this could help me split up the ins and the outs, but I don't think I'd have room to invent the entire circuit that I need to invent. So that's not really going to help me out all that much. It just helps me bridge pins to pins. Yeah, that doesn't help. All right, now get that out of the way. Let's build 2 filters, and we'll figure it out from there. Yeah, they're neat, but they're like, what am I gonna do with them? That's like this bin is the bin of regrets. This is the bin of regrets. Because there's so much potential on here, but so little planning goes into anything that I do with this. These are, you can buy these on eBay. Mine are older, but yeah, they're like specific types of breakouts that you can buy on eBay. They're pretty cool. They help when you're trying to do surface mount to prototyping board, to perforated prototyping. Surface mount to solderless breadboard. They're like invaluable for. Does invaluable mean they're not valuable? I forget. Yeah, anyway, 10Ks. I got a bunch of them here. So 1 to ground on the junction between the 2.7 kilo ohm resistors. 1 to ground on the junction. I don't know where these pins go. I think this one goes to this pin. This one goes to this pin. It's supposed to be for a decoupling capacitor. It's the same as inflammable. Yeah, so it's not flammable, right? Or no, inflammable means flammable? I don't fucking know, man. Does this one go down here? I can always ohm it out, but I just wanted to know. Because if that one goes down there, it's still not useful to me. 1, 2, 3, pin 4 is power. Right? Double check. Double check, double check, double check. Oh, 8 is power, 4 is ground. Okay. All right. Plot thickens. Plot thickens. So the 10K ohm to ground. Oops, hold on. Pin 4, that's this pin. So I need this pin to go to here for a 10K ohm resistor. Yikes. Bop, 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 bop. Make my decisions. Make my decisions. What am I gonna do? If I run ground to like there, I could do a 10K here and a 10K here, and then run that with a wire over to that pin. It's gonna be a mess. It's gonna be a mess. Also, I just take it from the other side and use it that way. Well, but what I'm trying to do is have fewer wires go to the underside of the board. That's my justification for what I'm working on right now. So if I have fewer wires going to the other side of the board, if I can make... Where's the one that I've been drawing on? If I can make this and this on the other side of the board, then I free it up for this piece of the circuit. In literally. I hate it. I hate this circuit. I hate this circuit. This sucks. I hate it. I hate it. Can I build this just with the perforator, with the breadboard? Would that be easier on me? Would that be easier on me if I just do this? I don't have the capacitors. That's the problem. The 22 nano and the 4.7N. I don't have it. I don't have them in through hole, but I can transfer them over to it. And then this will be clearer and easier to build. I wanted to make little modules that I just plug in and then try the circuit out. But it seems like if I've got all those op amps, we might as well do this through hole. And then at least I've got everything spread out in front of me. I think we're going to do that. I think I'm going to give up on this. I wanted to do like some soldering stuff because like viewers like to watch me do the soldering stuff, and I'm good at it. It's just that the limitations of what I have to build it on are starting to kind of pile up. I mean, I'd have to run wires to the other sides of boards and stuff like that, and then we probably wouldn't finish this today. So let's just like start over again. Let's just start over again. Fuck this. Fuck this shit. Fuck all this shit. Fuck it. Fucking fuck. If I don't have the through hole at 2.7K flavor, I'll make a little surface mount adapter for it. And that's just how we'll do it. That's just how we'll do it today. Fuck this. Fuck all this. Fuck it. Time is money. All that nonsense. So instead of this bullshit, that's gone forever. It's dead. What we'll do is we'll take an SO8 breakout. I'll take 3 of these because we'll put all our filters into this. Nates are pretty, okay? Okay. Just want to say, I really enjoy your stream. Been getting into this stuff. It's cool to watch somebody who knows what they're doing. Hey, man, thanks. Appreciate it. Yeah, we'll use these, which are just SO8 breakouts. So this means I can use surface mount components with the solderless breadboard, which is, let's be honest, it's a little easier just to plug stuff into that thing. It's a little less mentally taxing. I don't have to plan ahead as much, is what I'm trying to say. And I want to use the ones that are just dedicated to having a singular SO8 chip on it with nothing underneath, because these are kind of special. These let you run resistors between stuff. I'll be happy when this bin is empty, just so I don't have to think about these fucking things anymore, you know? So yeah, let's make up 3 of these little guys, and I'll plug them in to the solderless breadboard, and then I can just freehand build them. And then I can jump directly to making a circuit board if and when this EQ works out. We'll just do that. That's so much easier. That's so much easier, man. These are good as backups for when I'm working with tiny 85s. Because apparently I break them with a kind of a regularity that's, I don't know, some people like to lord it over me. Yeah, thanks for the kind word, Nate's. Hopefully I can remain educational as we get into some of the weirder stuff that we're going to be doing here. Because we're going to start working on Burn the Subs tomorrow. We're going to be doing Fusion, or not tomorrow, Thursday. We're going to be doing Fusion 360 until it is done. There will be no hang-ups like I'm having here. Because I need to get hardware done on that thing. I've got everything in the CAD program that I need in order to design the solid that's going to make up that axis. That's going to back that axis up. All right, so what I'll do is I'll anchor this down. We'll make 3 of these. I'll put them on the board. I may be good at soldering surface mount, but when I don't have a plan, my brain starts leaking out of my ears. Yeah, Fusion Thursday. It's like Thirsty Thursday, but it's not fun. I had more of the cider the other night. I really do think it's making me fart, but it wasn't as bad. Like, I really don't want to hand out that cider to friends and be like, hey, listen, buddy, when you have this, it's gonna make you fart. Like, I don't want to do that. You're gonna fart real bad if you drink this. But hey, free cider. I don't even know the alcohol content to it. I mean, I had a picture of it. Just don't tell them. Well, that would be interesting too. Hey man, does the cider make you fart? And they might not have this. What the hell was that? They might not have the same Apple hang-ups that I have. A friend of mine just got an Apple computer. He got one of those new laptops with the notch in it. I don't know how to feel about that. This is like the friend who was my PC gaming friend through high school. He got an Apple laptop. And then my other Apple psycho fan friends were like, welcome to life. It's like, what? What? Fuck? It really was like, welcome. You got an Apple computer, welcome. It's like, you fucking Kool-Aid guzzling bastards. Make it just sound like he became like a Hare Krishna or some shit like that. Fucking some cult thing. No longer a gamer, I know, right? The turtleneck cult. Well, they don't have the turtleneck guy anymore. I don't know. I mean, like, listen, if you wanted to run like Linux, if you wanted to run Linux on it, I'd be totally happy with that. He doesn't really play games anymore, though. He became like an adult, which is really dumb. Why would you do that? Right? Like, why would you do that? Was that a 37? Yeah, so it is a mixed bin. Chlorgol! Thank you for following. Ah, motherfucker. Alright, I'll have to fix that in a minute. No, it's partially leaded solder. I meant to get lead-free, but... yeah, this is another OPA 37. Same thing happened to my friend. He had a kid. I know, right? We're making an EQ circuit for my my lavalier microphone amplifier. All right, so that's a mixed bin. What is OPA 37's difference between the LF353? The LF353 is what I used in my mic pack, so I might as well keep it. I wonder if I've got a quad op amp. That'd be nice. It would help me. That's fine. All right, let's get more LF353s out of this bin and make sure they are such. Look at that. See? At a high percentage chance. I always have trouble getting lead-free solder to work as nicely as leaded. Put your temps up. You need higher temps. That's it. That's all there is. Where was the other one that I found? Wait, I thought okay, there it is. I need to make sure that I get 3 of the right part. I'll have to use hot air to get rid of the OPA 37. And then I'll probably have to organize this bin at some point. Put on some magnifying goggles. And just sort these out. You don't have it. See, this is what I'm talking about, guys. This is what I'm talking about. The bad reputation for lead-free solder. Listen. The fall of Rome. Leaded pipes. People were eating lead because it was sweet. Everybody goes, I love how the leaded solder smells. And I love how easy it is to work with. Well, listen, have a bit more of a hard time and don't use leaded solder. Get that shit out of here. We don't need to have all kinds of health problems down the line because you've been friggin' like snorting lead powder your whole life. It's not gonna happen now. There will be no health effects now. So all the old guard of like friggin' engineers and technicians who solder are like, it doesn't flow as good, so I don't like it. I like being counterproductive to health codes that fucking save lives, right? Don't be like that. I fucking hate. Anyway, a lot of people are like that. It doesn't flow as nicely, so I'm gonna get cancer. I'm gonna willfully decide to be exposed to a horrible substance my entire life. Now I'm using partially leaded solder, so I don't have much of a soapbox to stand on here. This is partially leaded. I've reduced it, but the crime bell curve had a correlation to the amount of lead in. Jesus, I'm sitting here doing crimes. The whiskers aren't really a thing anymore. They've changed the formulas around. They've gotten better at it. The modern lead-free is very good at what it does. Raise your temps. Have a temperature-controlled iron. Raise the temps. Work carefully. For lower exposure, you could also get partially leaded, I guess, but it's not a bad thing getting rid of the lead. Some people seem to think like your airplanes are going to drop out of the sky because of whiskers forming. Or like your small electronics project that you're soldering together in your garage is going to somehow fail because of lead whiskers or whatever the whiskers forming, and that's not the case. You need to be in some pretty extreme scenarios in order to have whiskers form. Yeah, better lead-free too. Better lead than dead. Better dead than lead? Free? Yeah, don't chew on it. Yeah, it just gets a little tiresome, you know? That's a little tiresome. It's like the metric versus imperial debate. Yeah, fume extraction is a good idea. I have a big fan on my back. If you've noticed, there's no smoke coming up off of anything. It's because I have a big fan at my, basically stuck up my butt. Just a big fan. And so that's venting all this stuff around the room. Usually I have the window open, but somebody decided to go outside, I guess. I think they're gone now. I think I can open that window. I also do have a fume extractor. I have a bathroom fume extractor that's been installed in this space that I could turn on if it gets bad. No, I think a lot of the mythical properties of leaded solder have been falsely appropriated to it. I think it's because people originally used lead-free and probably didn't give it the benefit of the doubt, and especially considering that they've updated all the formulations, and they're probably not working with higher temperatures because they think it's exactly the same as normal solder, and it's not. You know, the joints may not look as good, but you can still work with it just like regular solder. This is all over the place. There you go. Yeah, lead's pretty nasty stuff. I can't get this to like align properly. Hold on. There's barely any room for the pads, and we've got a lot of parallax because of the microscope's position. This is me giving up, by the way. I'm giving up on building these as modulars. Modulars. Building these as modules. I'm giving up on that just because I needed the freedom of the solderless breadboard. I probably have quite a few health effects now after a lifetime of being exposed to this stuff. Can't really pin it on anything, though. But I don't think it's a good situation. Too late for me, chat. It's too late for me. I've been exposed. Soldering surface mount is great. You just got to learn to not be as picky, yeah, if it's going to trigger you that much. I love doing surface mount soldering. Ta-da. Surface mount is my bread and butter. I appreciate it much more than through-hole. I think it's easier, especially considering that the resistors just literally have their values printed on them. The problem here is that the pad doesn't extend beyond the pin. It's under the pin, which makes it a little bit more fiddly, but not much. And I'm literally using the same view that you guys are seeing in order to do this. All right. You don't need secret codes. Secret playground codes. All right, we got to get this one off of here. Hot air, one way to do it. I think what we can do is do the super duper ghetto way of getting this off of here, which is to just add a bunch of solder to both sides and then flick it off. Right? There we go. That's one side. And here's the other side. And all we need to do is go 1, 2, 3, 4. Let's have a thummy war, and it's gone. It's gone, just like that. It was never there. It was never there, chat. I know you guys liked it, but it's gone. I took it away from you. And then we desolder the pads, and now we're ready to work again. Ta-da! Easy peasy lemon squeezy. And I can see the quickness by which I did that. I don't want to expose these pads to heat for too long, otherwise I risk lifting a pad. But generally, I'm not too worried about that. Just when desoldering, I figure it's better to be a little cautious and work quick. So, pin 1 to pin 1, which means I gotta go 180 degrees. $180 degrees. We grab dish. And we position it. Now, this is the anchor pin. Let's go all the way up and over. A little bit, a little bit, a little bit, a little bit, a little bit. Okay. That should be good. Make sure we're actually down on the pads, because there was solder there that could potentially push up some of the pins. We're good to go. Good to go. There we go. Just took a second to get enough heat in there. This is an LF353? Yeah, okay, good. I was like, oh shit, is this another one of the wrong kind? We don't like the wrong kind around here. Wrong kind of op amp. Hello? Oh yeah, I don't want to expose all those at the same time because there's no solder on the other side. Little bit of solder, a little bit of solder. I wish I could drag solder these. That would be much easier. I'm more comfortable in drag soldering. All right, get rid of the excess. Get rid of the excess. All right, here we go. So yeah, we should be able to put this together a little bit more easily than I was doing before. So let's get pins on these, because we need to actually output these to things. All these are our surface mount breakout boards. So now all of our pins are being routed to all of the pins on these things. So I can build that repeat circuit structure on the solderless breadboard, but I need to put pins on things, and the way we put pins on things is by using the solderless breadboard. I'm going to move this wire out of the way. Man, I was hoping to show off a little bit of surface mount soldering skill, but I guess we'll be doing that on Saturday. You guys should know, on Saturday, Julian is going to be here. Jules is going to be here, and we are going to work on building a piece of musical equipment for him. So if you guys want to see more of this hot soldering action, tune in on Saturday. All right, so moving in here. Bam. I have perforated prototyping board. What I need to do is I need to attach headers to it. The thing about headers. What's the thing about headers? Bother. What are you talking about? Why are you talking about headers? What is this? Where am I? What is this? So, the thing about headers is, if you try to solder a header, there's this one weird trick. So if I take this header right here, and I try to solder to this header, I try to solder something to this header. I turn on my iron, I got some solder on it. I'm gonna have to do this one-handed. I get some heat on it, I get some solder on it, and I try to just solder this header. And I go, okay, all right, I just need to solder this thing here. You go, oh, wait, nope, messed up a little bit. I got to come back here and I got to add some more solder to it. Let me just, okay, I got to heat it up. And what happens over time is that whole pin gets hot, and then the whole pin is capable of just moving around, and it gets misaligned, and the plastic gets soft, and eventually it just falls out because of the heat, right? So we don't want that to happen to our pins. It's very easy for that to happen, and now there's like, it's really fucking hot. I should have known. It's on thermals. Thermals should have told me everything I needed to know about this, about this hot fucking pin, But the thing is, like, that now very easily will come out, and it'll be hard for us to plug it in. Some of the nicer ones have like a little texture on the interface between the plastic and the pin, but typically these are very cheap, and so they are just like press fit or molded around the pin. So we need to keep that pin from getting too hot, and we need to keep it from getting misaligned. So what I do is I plug it into this. So I will cut little rows of 4 pins. I need a bunch of them. One. Two. And 3. 3. So we need 3 of those. 3 of them. And what we can do is we just bridge the gap. Pretty sure. We just bridged the gap. Something popped. What the hell was that? Scared the shit out of me. I tried to get my VR working the other day because I wanted to play, what was it? Into the Reach or whatever. And I bought like a $30 game, right? And I was like, yeah, let's do some VR. The fucking thing doesn't work at all. I'm thinking maybe on Friday we might take apart the VR headset and figure out why it's so fucked up. Because I think it's a hardware issue, and I've had it for over a year, which is a problem because that means it's out of warranty. Yeah, the game Tomato was playing the other day. It looked really fun. I still haven't finished Alex and stuff too. I need to do those games, man. I need to finish those. So many games to play, and all I want to do is play Satisfactory. That's all I want to play. I still need to finish. Yeah, those stickers are actually no longer legal. But yeah, I don't know what's going on with it. It's very moody about where it's plugged in, but this time it was plugged into all the exact same stuff. So I don't know why it just was not working at all. I'll futz with it a little bit more tonight. Yeah, rest in peace, expensive dusty paperweight. I put a new headpiece on it, a new goggle piece that actually mounts a lot better to your face. And I have prescription lenses in the damn thing. Those cost like $60, I think. The prescription lenses help a whole hell of a lot, to be honest. Like, I can actually read text now. My prescription isn't even that strong. That's the thermals. So knocked on one of the big pipes at work, and the system now somehow knows water's being used, so it starts pumping more water. Ugh. Yeah, fire extinguisher water is disgusting. So yeah, I don't know what I need to do in order to get it working up again. Sometimes it'll just start working, the VR headset. It'll just kind of start working for me. What I wanted to do was be able to incorporate it with Fusion 360 so I could like see my parts in VR before I committed to like building them. But it didn't, I don't know why it didn't really work out. It should be a thing. Fusion team should get on that because that would be hilarious. If you could like do full sketches and like extrusions and stuff in VR, that'd be a cool tool. That'd be a very cool tool. I mean, I know it's like useful for architectural planning, but it would be hilarious to do it for like any other part. It's like, yeah, I want to 3D print a bracket. Let me get into the virtual realm. Let's go into the virtual realm and design a bracket. So yeah, this is my cop out, by the way. I'm copping out and I'm building these on the perforated prototyping board instead. Which just means that I get a little bit more freedom to juggle things around, and the circuit will make a little bit more functional sense, I guess. The only problem is we are introducing a lot of areas for sort of weirdness and noise, in that this stuff isn't really soldered down. With analog circuits like this, analog audio stuff, I would prefer to solder together a circuit in sort of a spread out fashion, because then all the connections are perfect. You're not subject to whatever dust fell in there over the previous years. And, you know, all of your different circuit connections don't have all this metal hanging off of them. But if we are to put this on the O-scope to characterize it, then this will probably be a little bit more useful. We'll be able to see the wave as it goes down the line and stuff like that, hopefully. Assuming the gain is right. Same time. We're actually rigidly locked into that time. Same time on Saturday. I have Julian here. We're going to build a thing. Julian's going to noodle around and probably fight boredom the whole time. We should have a pretty good time. So yeah, I don't think I'm gaming this week. All right, so now hopefully we don't need any more solder, but we probably will because I'm going to have to incorporate different capacitors into this thing. So these caps over here are specific value capacitors. So if we need these in the circuit, well, I'll have to get my little capacitor measurement thing. But yeah, if we need those specific values of resistors or capacitors, then I'm going to have to build more of these. All these are misordered female headers. Now you call them male and female. You should know that that's just what we call them. And that's just how we're doing it. Okay, so you have these fit regular pins. These are extremely valuable. The ones that can fit regular header pins, because that means I can build something with these and fit a module onto it. Well, the problem is they're so special that I'm never going to use them. They're like that item in your inventory in a game where you're too scared to use it, that special thing. And you end up never using it. So these are the misordered ones. So I ordered these wrong ones, and they don't fit, right? So what I do is I use these in order to mount surface mount components to the prototyping board. That's where these are particularly useful. Right-o. So we need to build this circuit like a billion times. Where are we going to put it? It seems like right here would probably be a good space. I mean, I could also build it right there. These are not, that's just storage over here. So let me move this over to storage. We never ended up doing multiple of the graphic EQ. I'm doing 6 of the parametric because I think the parametric is going to do the job a little better. Sometimes for Saturday, but not at time. Every other stream is at exactly the same time. Yeah, it is. It's going to be the same time. 12:45, 35 is really when I start up. We'll hang out for a minute, and then I'll start up the stream, and we'll get to building stuff. Now, the parts that I don't have for this thing are the plexiglass cover, and we didn't figure out if I had exactly the right standoffs. There'd be a little bit of drama in there. Those are soldered together, actually. I need to fix that. That looked weird. I think I caught that. All right. Pin 1. Pin 1 on these things is marked. It's got a little 1 next to it. I'll leave a couple rows between those, and hopefully we can build this somewhat of a civilized fashion, right? I'd really like to use surface mount resistors and stuff on these. Just make every component surface mount, but do it in here. That's all right. Nah, I won't do that. Okay, so let's get back to the circuit, right? What is this circuit going to look like? Like that. But without this stuff marked out, because we can now just incorporate these parts. So the 22 nanofarad and the 4.7 nanofarad, we're going to have to figure out what values I want for that. Because if I have my 6 bands, I need to get the capacitors for the 6 different bands. That's going to be a tough one to figure out. That's where the surface mount components are going to be. So for now, what I'll do is instead of the capacitors, I'm just going to put in a blank header so that we can do all the calculation and stuff at a later date. Well, you know, a couple hours from now. So I'll cut a couple of these. That means we're going to need 6 of them, right? Hopefully we have all the through-hole resistors, otherwise I'm going to have to make more of these little jumpery guys. But for now, I'm going to count these as being the miscellaneous capacitors. And then I guess we're going to need resistors too, and I'll have to figure out what value those are going to be. Boy, oh boy, it's a lot of work. Looks like a simple circuit, right? But the problem is we got to do it a bunch of times. Might have been better for me to just design a module and get a circuit board made. Just jump the gun completely. My throat's getting a little sore. I'm going to take a sip of liquid, believe it or not. Okay, let's get those in there. Those are ready to go. All right, so we can build this by just going from one end to the other, right? We could just start at the beginning. Start at the beginning. And I'll just go through it. So our the first things we're going to need is power and ground going to each of these. Now, on this perforated prototype, god damn it, on this solderless breadboard, I just have power and ground running to all of these. Did I isolate any of them? For some reason I isolated this power, but I'll hook it up again just so that it's there. So I'm going to need jumpers. See, like this is its own category of disorganized that I don't like. I prefer building the circuit, and then I could organize everything a little better, but we got to make progress on this thing, so I decided to jump over to this. Where's my jumper kit? Yumpers? Where are my yumpers? There they are. Get yumped. So I need a red wire. Where is my tweezers? Tweezers! And a red jumper should bridge the gap and bring power to the rest of this piece. Yeah, I found out with the microphone pack, when we built that part of the circuit, the part that was missing, the part that I forgot to put in, was the entire virtual ground connection to the op amp. So it had nothing to compare against. That's why there was no audio output at all. Very strange. These don't need a virtual ground, I guess. These are kind of making their own. and it has to do with the way that this filter operates. So we've got a potentiometer as our input and our adjustment and our output. It's across all of that. Input, adjustment, and output. So in order to get that together, I need to connect pin 1 and a resistor to pin 2. So this will go up like this, I guess. We'll try to make this compact. Where's my pin 1 is up here. So pin 1 and like that. So that's the connection. So it's actually output, middle, and then the input's all the way on top. So I'm actually going to do all 3 of these at once. We'll see if we can make all the circuits at once. Like that. I need a bunch more. Luckily I got them. All goes right there like that. That's going to get in the way. It really is. Our output from the second filter. Output from our second filter is on pin 7, not pin 8. That makes it a lot more difficult for me to hook up, because pin 8 is a power, I think. Pin 8 is power. Yeah, V+. Pin 8 is power. So I'm going to have to use a little jumper there to jump over that line. Damn it. That's annoying. So I can just do, let's see here. What do I have a bunch of? I need to go over 1 row of holes, huh? I think that's the little blue ones will do that. So pin 1 is here, pin 8 is here. That's what I need to jump over in order to get this over to that row. I'll do it 2 in. Wait, we need to have the edge be available for that. So I guess I'll do that. And then this goes up here like that. And then that will go to plus. So let's do that one as well. And I'll go down the line doing that to all of them. I am running out of jumpers. I gotta buy another kit. I mean, this project has become kind of extensive. I'm not finding the right size. And back you guys up a little bit so you can see what I'm doing. Yeah, it's a little better. Boy, it would have been nice to figure all this out ahead of time and just be able to like punch all this stuff in and make it look super easy. That's not really what we do here, though. That's not really how we roll, chat. We don't really do that kind of stuff around here. I wonder if running through 6 of these is going to like massively alter my audio. They were putting them in unadjusted so we can figure out what the adjustments will be, right? I guess the other potentiometer is the one that's going to get locked into place. So that's these 3. Now I need a jumper over to go get to power. We're just taking it 1 connection at a time, right? So we don't mess up. I want to mess this up. Like I did the other one. Like I did the other one. I had to spend so much time like troubleshooting it. Which is always going to be a thing, but... Alright, pin 8 goes to... Hold on, double check. Pin 8 is definitely power. Okay. We were soldering a minute ago. That's why the thermal camera. All right, power. I need more gray wires. More of the gray wire. So that I can wire every single filter up to power. Power. 1 more. Yeah, quad op amps would save on a lot of these extra doodads that I'm putting in. Quad op amp. But I don't have any quad op amps. These OPA 37 and the LF353s that we're using, This is left over from other projects. I think these are the op amps that were used in the brain imager, the non-invasive brain imager that I worked on. I was trying to build them like a... Why is there a t-shirt tag in here? I was trying to build them a surface mount version of that a long time ago, and I ended up ordering a lot of parts. But they were using these as instrumentation amplifiers because they were treating everything as if it was like audio. What they had is little light sensors. Hey, Louie, rating with a party of 11. I was explaining a, what do you call it? I was explaining a project that I'd worked on. That's the reason why I had like a ton of audio amplifying chips. We've kind of given up on soldering. We were doing a bunch of soldering earlier, and I decided to use the perforated prototyping board. Sorry, the solderless breadboard. Hey, 11 months, make a wish. I wish Louie didn't subscribe. Anyway, oh man, thank you for the raid, dude. Yeah, we're working on the lavalier microphone pack that I have, that I built myself. It's this lav mic here that I use. I have it on a cable, not on a wireless amplifier. And the reason behind that is because I can't take you guys to the bathroom with me as a result. You guys don't get to hear me grunting in the bathroom trying to do my business. This only has enough room to get me out of the room, right? I can leave the room and then I'll get caught by it and tripped. So what we're doing today is I have got on this prototyping board, Baba Yaga Slob. Thank you for following. What I've got up here is this entire microphone amplifier circuit. And I was plugged into this a little while ago, talking with you guys just on this lav pack. You see, my lav mic is very special. It's super duper sensitive, and it has a very nice audio band to it. It's a movie quality lav mic that was sent to me by a friend. I'm doing my best. I'm trying to make it work perfectly. Fluid corn. Speaking of the bathroom. Anyway, thank you for following. Corn liquid. High fructose. So anyway, my microphone is very sensitive. This circuit replicates the audio pretty much 1-to-1. It's actually used for like nature recordings, and I built a PCB for it back in the day with curved traces. But anyway, built a PCB for it back in the day, 1-to-1 audio replication. Then I go and I buy a new mixer, and I'm like, yeah, I could probably make this sound right in the new mixer. It doesn't sound right in the new mixer. And in the new mixer, I don't get the level of control that I have in OBS with my digital sound plugins. And so what I'm trying to do is make an equalizer like that, and then maybe down the line make a compressor that does that and is adjusted appropriately for this microphone, so that I can plug this mic into my new mixer and get exactly the same sound out of it. Without this stuff, the mic is just terrible, right? You can hear everything. You can hear me scraping my beard. You can hear my like barely breathing, like everything. My heartbeat is almost audible through that thing. So we're trying to build this into this space. First, I need to figure out what the circuit's going to be. So for that, the actual microphone circuit came from this guy's website called Elliot Sound Projects. And he has something called Project 93. Let's Control Z that away. Project 93, which is a phantom power lavalier microphone amplifier. It's basically, you take it up to a voltage level so that the lav has a little bit of power behind it. Its little wibbly AC gets put into an amplifier. It creates a bit of a virtual ground where it can have kind of like a reference point for zero. Like ground in an analog audio circuit is an offset of DC so that you can have waves exist. That's what that's doing. Then it's amplified to the point where you can put it all the way into an audio system, and we create the opposite wave. By creating the opposite wave, what that's doing is it's giving the differential audio, the XLR differential, a difference. So you have a wave, and then you have the opposite wave, and then the difference between those two makes the wave. And if there's noise on the line, common mode noise, both of these get a positive spike or a negative spike. And if it goes in the same direction, then it gets filtered out by the differential stuff. And then you've got this unholy matchup between a bunch of transistors. And that unholy matchup with a bunch of transistors, what that's doing is, for the power of your electronics, it's removing your audio wave from your power source. You got to kind of move them apart from one another. Yeah, this will mean a different circuit for each microphone, because one mic does not the same filtration make. I mean, your microphone should probably, especially if you're getting into multiband EQs, each mic is going to be filtered a little bit differently because each mic has a slightly different frequency response. So what I'm doing is I'm building 3 circuits, also from Elliot Sound Projects. So what we've done is we've taken this project and we have severed the connection right where, excuse me, hold on, I got a cough. All right, that's a little better. What we've done is we've taken that connection and we'll sever it in just the right spot so that we can insert our own new stuff in there. We've already tried this guy right here. This is a graphic equalizer. So the graphic equalizer takes in all of the frequencies on a bus line, filters what it likes, what it wants to hear, you know, whatever you tune it to, and then it'll output all of it on another bus line. We're now doing this circuit where each stage of the way gets all the frequencies and it'll add or subtract them from the actual audio that's there. It's a slightly different method of doing it. I need to try it out. I need 6 filters. So I am building the one filter of this circuit 6 times. 1 filter 6 times. And since we have dual op amps, that pinout on those pins is correct. So we're going to follow that. So I'm just starting to perforating, prototyping, whatever, the solderless breadboard it onto the circuit right here. That's where we're working. Whew. Man, that whole explanation is going to cost me my voice. All right, so I'm looking for jumpers that I can use to get power and ground into these things. These bus bars on the sides are our powers and grounds. Doing analog audio stuff is crazy, right? Like, I enjoy this. I have fun with it. A little bit of pressure on it because, you know, I want stuff to actually happen on stream. And unfortunately, this middle part for all the electronic stuff is a little bit boring. But hey, if we tough through it, we should get good results. I don't have jumpers. I'm like out of jumpers. I need to buy a new kit. Hey, what up, Tim? Thanks for explaining it again. Yeah, in the past, people have said I should make like a video at the beginning of stream just so I can have the clip of me explaining it. I have tried that in the past, but for better or for worse, you know? I'm probably going to need more. Well, I got all the connections to ground I need, so I'll just do that. That didn't feel good. That didn't feel like it went in. So these are the grounds. That's too big. Let's see if we can find the right jumper here. Gray wire, I think, is just the right length. It's funny, I don't need the super long ones for these because the ground and the power are like right next to where they should be. But there's just enough of a jump there. It's, you know, the projects around here require big explanations. It's kind of annoying. What are you doing today? I'm mopping the floor. That's what I should say. I'm cleaning up around here. What are you doing today? What I should have done. What I should have done so long ago. I know what I have to do. I'm just trying to muster the courage to get it done. All right, so gotta put these things in like this. I don't know if they're all gonna adjust in the same direction if I do it this way. If I do them facing in like that, I think they need to be like this for them all to adjust the same way. I'd like the directions of these to not be confusing, you know? So these are the potentiometers that adjust the frequencies in and out. I have, these will be placeholders for the capacitors, which will go on the wiper. That's impossible. Shit. Where's that gonna go? Hold on. If I jump over to the other side of the board, I could do the 22 nanofarad, and then I need to grab a 10K resistor, and then I can just go up the line on the holes. Oh, man. This is going to be tough to build. Let's see. Well, let's try to find 2.7 kilo ohm resistors first. If I got through holes of those, because that'll be nice and easy. I got a 10,000 of those things that got to go in. 10,000 2.7K resistors. I probably don't have enough, to be honest. If I need 2 per 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I need 12. I don't think I have 12. I have 12 10Ks. Those will be nice and easy to get in. 2.7K. I have plenty of surface mount ones. That's the other thing, is that I got those. Seven 7.5, 5.6, 3.9. I got all of them. 3.3. That was the other one. Use those. The other filter. This one's unlabeled. Wait. 2.2. I don't have 2.7. All right. I don't have 2.7. We're going to need to put 2.7s in here. So I'm going to need to use the jumpers, the yumpers. Very well. Made this decision. This is what I'm talking about. I got more surface mount parts than I do through holes for these kinds of things. 2-point. Those are the 10Ks. Yeah, 2.7 I got tons of. You can't see because there's text all over it. I got tons of them in there. So we're going to have to do the surface mount method of those. I'll just steal some of the headers that I already cut. And I'm going to have to make a bunch of them. I got to make a bunch of them because we need one between the... Oh, man. Between the input and the negative. And then we need another one between pins 6 and 7. So, at least the ones between 6 and 7 and 1 and 2. Those will be easy enough. Now let's get to soldering. The same method here with the soldering is basically I'm just putting the surface mount part onto those header pins. I'll work from there. And I'll work from there. But the prototyping board will take up some of that excess heat and allow me to work a little bit better. Keep me from melting things. Turn that on, get that ready, get the solder. I'm like running out of solder too. Man, that'll be the day when I have to rage quit a stream because I'm out of solder. That'll be a hell of a day. Solder day is a very dangerous day. All right, so we're putting this thing on there, this 2.7 kilo ohm resistor. I have to make a bunch of these, don't I? Well, I'll have them for the future, at least. I'll have to put all these custom component breakouts into like a bin or something when I'm done. Usually this is a less destructive process, but yeah, here we are. Here we are. My surface mount parts outnumber my through holes. Come on, settle to the middle. There we go. 1. Ow, ow, fucking ow, 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 ow. Ow. Okay. That's 1. Look on the next one. That is actually hot. See, there's no, you can't see it anymore. You can see in the thermals when I actually am pushing the limits of my pain tolerance. Next resistor from the bin. Right here. Flip it over. Or drop it. That works too. Man, that's way out of focus down there, huh? Bring that guy up here. Drop it a little bit. My hand is cramping. Oh God, okay. All right, glucose levels dropped. Fairly easy to get cramps as a diabetic when your glucose level's doing a big move. So my hand is trying to become a claw right now. I gotta kind of wiggle it around a little bit. Keep my fingers moving. I don't know why that's a thing. Why is the buildup of like lactic acid more in diabetics? Wow, I kind of melted the shit out of that. Gotta be careful because these tend to get melty a lot easier. All right, that's 2 of the 2.7s. Ow. We need a lot of these things, unfortunately. Should we concentrate on just building one filter for now? Or 2 filters, rather. You need to have it invert back over. I'll concentrate on building 2 of them, and then I can spend my Wednesday doing this tedious chore. So we'll build up one of the filter blocks, and then I'll repeat the circuit off air. So we can actually show some results today, right? When I do this in CAD, it'll be so much easier to just cut and paste the circuit block, put it all together. It's going to require a lot of components, though, in the mic pack. Whoa, dropped that. I dropped it, but it landed correctly. Okay, all right. So you're gonna tombstone on me, you little bastard. Nope, stop doing that. Is anybody left from Louis' raid? Like, what is Bother doing? They all fall asleep immediately. All right, that's another one. The last of the 2.7s until I come back and do this again. I need 2 per, like the heat cam. Yeah, man. Unfortunately, I don't have like a heat microscope. It would be much cooler if I could somehow microscope lens the thermal camera, but the optics for thermals are very expensive. It's not quite what you think, right? They're very expensive. I think you need gallium arsenic lenses. The warmth would be overglowing. Well, not if it gets. I mean, it's like a little dot lens. It's actually looking a little weird today. It's getting a little. I think the unit itself is getting a little warm. When it gets warm, like inside of the enclosure, it starts to give weird visuals. But if I did microscope lens it, the heat would be much different. It's like 640 by 480 visuals, so you don't get a lot of clarity in there. But it would be nice to be able to show like close-up views of the things getting warm, because you can see like it can get really close to stuff and give you a decent thermal visual. Yeah. But I put it on the camera so that I can co-witness. Label on the last one is different from the others. 272. 274? Is that a different value? Let's get the multimeter on this. Oh, my multimeter is out of reach. Okay, I'll use one of these. It's not that hot. It's the distance is different. Did you? There we go. That's 2.7K. As is this one. Oh wait, they're influencing one another. 2.7, there we go. It's 2.6, but that's because we had 2 2.7s in parallel. Wait a minute. It just shut itself off. Come back. Oh, 268K. Dun dun dun. So yeah, that's a different value. This is what I was talking about with this kit of resistors. It's routinely wrong. I had to organize them into another thing in order to make sure that they weren't wrong, and then it turns out a lot of them were. Yeah, I'll have you know that the back seating robs you guys of the wondrous knowledge of how to troubleshoot. What would have happened is the gain on one of the stages would have been weird. And it would have taken me a little while to root out the bad resistor that was causing weird gain. I'm going, oh, that's the wrong value. And you guys would have been able to gain a little bit of knowledge of troubleshooting, but you don't get that now because you backseated. I gotta have steady hands here. My hands just aren't steady today. Nah, this would have been like hyper annoying for me to troubleshoot, so good thing you saw it. I just have to lay down the law like that whenever it happens, because otherwise people try to even fucking backseat my pancreas, which is going on right now. All right. Stop backseating. That's the line. You should be far away from that line. Okay, so I've got 4 2.7 kilo ohm resistors. Tried turning it off and turning it back on again. I've done everything. All right. 2.7 kilo ohm resistors, right? I've got all 4 of them now. So I need them from pin 7 to pin 6 and pin 1 to pin 2. Well, that's easy enough to do. And we're just going to build one of these for now, and then I'll repeat the structure for everything else. So 7, 6, 1, and 2. Let's get that hair out of there. It's a beard hair. It's a beard hair, okay? It's a beard hair. Pins 1 and 2. That's easy enough. You gotta watch out for parallax of these things. Pin 1 and 2. That one's a little close. Well, that's all right. We can just put it right there. 1, 2, 7, and 6. So 1, 2, 3, 4, 5, 6, 7. That's these two here. Somehow that doesn't seem right. Wait a minute. Oh yeah, because that has to jump over to that. That's right, because that's ground. Okay, so that's correct. Oh, you ever sniff? You ever just like sniff in and it gives you like, you feel like you've gone underwater? That's what I just got. I got water like shooting up the wrong part of my nose because I went. So sometimes things like this happen and you're like, how did I survive to get to be this age? Like, why am I still alive? Like, the human body is just like fucking poised against itself. I had water shoot up my nose because I sniffed. Man, all right. Felt like, you know, that pain from having water shoot up your nose. All right, so back to this. We're looking for 2.7 kilo ohms from the input to the negative pin. So the input's going to be all the way up here. The input's up here, and now we need to go to this pin with that. I had a saliva gland shoot water while at the dentist. Hot damn. That's intense. That's impressive. I'm impressed. So the input is on the other side of the potentiometer. The potentiometer is these 3 pins. So we put a 2.7 right here like that. That'll be our input. I can put the opposite one on the opposite side over here. Now we're trying to make this compact as well as I can. I don't know how that's gonna work, because we do have a lot of stuff. We got a lot of stuff that needs to go into this thing. Move this over one. So that's our, actually, it's not, no, it needs to go in a little bit. It needs to go in here. I'll move it over like that, because that way I'm not blocking, because this needs to go down here. It's because I don't have the right values. You know, I've got more surface mount than I have through hole. Just the unfortunate reality of it. I mean, it makes it pretty clean, right? You can actually like read what the values are. The 10K ohms are going to be through holes, though. So betwixt this one, we're looking at the right to now. So what we're looking at is this connection here. To the 2.7K. And this meets up with its buddy, the other 2.7K. Yeah, it takes a little long. Oh yeah, if you buy the precision like low wattage resistors, their leads are too thin for the solderless. The only reason that I'm able to do this well is because I ordered the wrong female headers and they don't fit square pins. So the ones that I have, these ones here, I bought a lot of these, like a lot of these. So this makes more sense, right? These don't plug into one another. They just don't fit. So that's why I have this method. And then these make nice little metal cups that I can use as the pads to solder resistors to. And capacitors. Okay, so we need to go from that pin to this pin. Damn, that is annoying. Yeah, and then this pin is the output, which goes to one of the pins of this, that goes to this thing. So it's in, ground, out, or in whatever out, in whatever out. So I'm gonna have to do like a weird jumper to get over to there. Oh my god. This is annoying. This circuit is annoying. So yeah, this is our input. I need to go from up here to down here. So I just need a jumper for that. Just a jumper. Yeah. I don't know which one's shorter than that. Let's see if I can find one. One pin shorter out of the jumper kit, out of the yumper kit. The yumpers. Because you can't see through this plastic. Oh yeah, you can. Yeah, in thermals. So the heat of my hand, the long wave infrared that my hand is giving off, is going through the plastic. Pretty cool. Shorter than orange. What's shorter than orange? Yellow's longer. Don't tell me gray is the one pin shorter than... No, I don't think it is. I've got a lot of oranges, though. I could just use that, and I could squish it a little bit. This kit sucks. I've dropped it on the floor many times. Lime? I think you overestimate the number of jumpers that I have in here. I think it might be gray, though. Oh, wait. Small red? Hold on. How does red measure up? Red is one pin longer. Damn it. Damn it. I think it is gray. But gray's like 2 pins shorter. Yeah, I think it is gray. Is that the next sequence in Roy G. Biv? Damn it, I need more grays now. We're running out of holes too. That's the... Sounds like a personal problem, but it is. We're running out of holes, officer. how am I going to get, I need to get this over to a capacitor that goes to a 10K, that goes to a bunch of other stuff. Damn it. Yeah, this is fast becoming unmanageable. I need to go from here way down to here. That might be doable in an orange. It might have to be a red. It goes to the wrong side. I need to be on this side because this is the output. So yeah, that's a red. Once I figure this all out, though, I'll have a form that I can follow for the other ones. It's just when you do that, you're cutting off all this. So if I am to do anything else, well, that's ground. That one is our output. So that'll be the filter out. This one is the center pin. So this one's going to have to get snuck down somewhere that I can work with it, unless I jump it over to this side, but there's stuff over here. So, oh lordy, this is going to get complicated and or restrictive. All right, what's next? So we got both the 2.7Ks hooked up. Those get a 10K to ground at their junction. Oh boy. So where these two meet up here, I need a 10K to ground. The 10K I can sneak in over there and get it over to ground right here. So those 10Ks I have plenty of, and they are through hole. It is fruit punch, and I am thirsty. All right, so let's do that. I'm gonna bend this over. Where are we? Actually, we could do it like this. We'll do one of these. Just like that. On the internet, nobody knows that you're a horse lime. That's what I think of when I see gonads suggesting lime to me. All right, so this 10K, I'm gonna sneak in to ground. Let's, here, I'm gonna pluck this for now. So that goes there, this goes right here. Thurston Waffles. Is that making a connection? I guess it is. It just seems a little dodgy. Okay, so like that, and then this will put back. Man, these really need to be the type that like lay down. All right, and then I need to do this to ground, so I'll just move this one in one. And I'll put ground across here. There are tools where you can actually plan out your solderless prototyping board. Those are kind of cheating though, right? It's like a little too organized. It's a little too organized. We need some chaos. My problem is I try to do everything a particular way, and I try to do it neatly and nicely, and then I end up getting in my own head about it and not finishing it because I need it to be just the right way, and I need to let go my inhibitions and just let my circuit be a little bit sloppy. There's already a connection over here to another part of the circuit that I need, so I'm going to have to like go way out like this. But yeah, this is the same thing that happens to me in games like Satisfactory, where I will set expectations for myself and try to keep to my principles, and then end up just not finishing what I'm doing because I'm too far in my own head. In your head. Okay. So, I mean, this circuit is not complicated. There's just some weird things about it that are tough. Like, this is just a bridge of resistors here to bring it into a particular value range. And what we're doing is we're taking those, we're replacing those with resistors. So if I add 10K to any of the other values that I would be putting in there, I don't need the 10K ohm resistors. I should probably have them so that we don't have to confuse the tables of values that Elliot has produced. I don't have a dual gang pot, so I don't have that frequency adjustment immediately available to me. I just have an expectation of where I want my frequency adjustments to be. They don't have to be exact, but they can be close. Ah, right on my face. Gross. Anyway, Tumik, thank you for following. So Elliot has like a value table for these resistors. We're gonna put a fixed item in there. His value table, I think he kind of like moves it towards commonly available resistor values, I think. But it'll be a bit of a struggle. But for now, I'm going to leave blank components in the spots where those are going to go. So what we need to build is we need 22 NF capacitor. It doesn't need to be 22. It's going to be some other value as well. Those capacitors vary in value depending on what range your parametric filter is going to be adjusting. I guess they're like the limiting range of that. But yeah, and then the 10K is going to be, of course, the amount of adjustment that we're putting on the thing. So I need that center tap and ground. Is that all? That's all it does? Center tap, pin 3, and ground. Ah, jeez, how are we going to do this? How am I going to do this? That's the wrong view. That's wrong. What are you looking at me for? Okay. I also have like random components, like these random capacitors whose values I don't know, that I could put in instead. I'll put in random capacitor. What did random capacitor ever do to you? This is just for 2 filters in the parametrics part of this. So we're not using the lower filters that I've populated. We'll just consider them to be there and see if we can't build this as compact as possible. This will also tell me how large each filter block is going to be in this design. So all right, let me see here. The center tap, which by God, the center tap is a lot of stuff going on right now. Let me get my pointing device so I can bring you through my thought process here. I'm trying to bring you guys along with me. So this pin here and this pin here, this one's already out, right? So this pin here, we could jump down to this area and we could build the filter down here. We're going to need this. So this has to go to its own capacitor. So I may have to cross in front of the entire thing in order to get that down there. Then I can bring this pin down. This sucks. So let's see what kind of jumpers I can put in here, because I can bring this down and then this one can just natively be close to that. I can put the 22 NF literally just right under this. It's weird how the circuit is compact in one area and then it just goes into chaos in the other one. Wait, no, that pin doesn't directly get, it's the center pin that gets the 22. So this goes somewhere else. Pin 3 goes into one of the variable resistors if we were doing it that way. So I'll put a blank component socket there for when we determine the value of that component. So that's what that is. That's a blank component socket that goes to pin 3 and goes to the other blank component. And those two, oh my God. Okay, hold on. Those two get a 10K ohm to ground. Okay, hold on. Oh, hold on. Oh, okay, hold on. This is crazy. The circuit is nuts to build. It's very strange. I prefer my digital electronics at this point. Boy howdy, wouldn't it be nice? We could jump to digital eventually with this project, but so yeah, I've got a 10K ohm going in. So here's what we're looking at, by the way. We've got, yeah, that's a weird technique, right? This is the junction that I'm putting together right now. These 3 are what we're putting together. That one's the connection to pin 3. We're gonna have to have a capacitor going to ground on that. I don't know how I'm gonna be able to do that. I mean, the fact that there's 1, 2, 3, 4 things connecting to this junction that's tough. That's very tough to do. So I got a 10K that goes to ground. Oh, I didn't bring the, ooh. My car has a propane tank in the back. Uh-oh. My car has a full propane tank in the back. I gotta get that out of there. Now I got my job cut out for me in about an hour. Anyway, yeah. There's a lot of stuff right here. I'm just trying to get it all together. So that would be pin 6, no, pin 5 goes to a 10K that goes to ground. I think I'm gonna need this to come out of here, because if one of them goes to ground, but they're both connected to the same thing, which means I need to, yeah, I need to move it out to another pin. Damn it. This is weird. This whole circuit sucks. There's too many connections. Ah! Okay, that went somewhere. I don't know where that went. Too many connections. Let's make another carrier. The reason that they're the weird surface mount, like modified surface mount holder, is because I have more surface mount stuff than I do through hole. So I'm able to find the values of these fairly easily in surface mount electronics. So that part of the circuit is a capacitor to ground, a resistor to ground, resistor to the other resistor to ground. Oh boy. So I've got one. That would also go to ground though. So that would be this. I gotta break down the other circuit. I don't have room to work. Dang it. I'm linishing back my expectations until nothing is left. Just gonna keep some of the components around for it. Okay. So pin 5 goes to one capacitor that goes to ground, a resistor that goes to ground. I mean, I could do like the capacitor here and then make that, take that over to ground. There's a lot of weirdness that I'm trying to work on here. To do that, then this will come in here. And that'll go to ground. This is like a big puzzle, building circuits like this. It's a big puzzle. And then I can pull that out of there. So that's the cap that goes to ground. And if I pull that out and I jump over that other part of the cap, bring that to there. Now I can have, I need a 100 kilo ohm. So that's the unknown component. And that'll go to a different resistor and a different capacitor. One goes out to another thing. Looks like I'm gonna have to jump over again. It really, like, just because these are two components, like the component bridge is only one gap, that makes it very hard for me to work with, because I can't run it over to here or anything like that. It's a strange arrangement. Like, that goes to ground fine with that 10K, because I can bridge multiple holes to the 10K ohm resistor. With the unknown values, yeah, it's just going to be the way it is. Actually, if I do... hold on. I'm thinking. If I do them like this, and then I do one going up and the other going down. Because like one of them goes 10K to ground, and the other one can jump to a different part of the board with the 10K. So I did them like that. And then, geez, this is cooking my brain, chat. My brain is cooked. My brand. Like if this were the capacitor, that would go there. I'm doing this on the air too. This is like all of my puzzle solving skills, but there's not, that doesn't actually fit. Damn it. Damn it. Nothing is working. Hold on. I think now. Pin 5, 100K, 10K ground, C4 ground. So if I did 100K like that. I can put a 10K here to ground. This is like ridiculous. What is this doing? And that would also be the capacitor to ground. The capacitor to ground is the tough one here. Because I don't have... That's power. What am I doing? What am I doing? You guys are going to watch a mental breakdown live on stream. Because, yeah, the capacitor could go there. I would take the capacitor to ground. Now, this would be a lot easier if I had a capacitor that could bridge that gap, but I don't. So let's not... I keep lamenting that fact. If I take a jumper down to here, and I take a 10K to ground... Yeah, that's what I'm going to have to do. Okay, so let's take a jumper. Man, this is convoluted. There's probably a better way for me to put this together. But it's not readily apparent to me, so I'm having a bit of trouble. So yeah, this one here, jump over that gap. Oops, daisy. Jump over the gap. Now, technically, this and this get a 10K, or I can do it across here to ground, and it'll be easier to see that it's going to ground. But I've run out of spaces. I would like to move this up, but I can't unless I move this down. I guess I'll have to. Okay, move this down, move this up. Oh, but wait a minute. Yeah. Move this up. Okay, and then this will be the input. With another... Oh, God, this sucks. All right, 10K to ground. It's not going together kind of like it is in the circuit, so... So, let's see, that doesn't directly, it's this one that gets 10K to ground. 3D chess, yeah. It really is. I mean, look, you can be very sloppy with these circuits, but I just wanted to put it together so that it was, like, apparent what structures are doing what. But it's kind of like, it's breaking my brain. I don't even play chess. Yeah, there's probably a better way to build it if I had through-hole components and I was, like, utilizing this, the jump there. Yeah, so where are we with this? Let's see. I put in this right here. I have this mega bullshit junction I'm putting together right now. So, and then I've got these two in as well. And this, yeah. So what I need to do is I need this one that goes to these two and into the potentiometer. So let's see. There. Capacitor, one of the resistors. This is for the other one. Put another blank one in there. Yeah, really, the crossing wires is the worst part about this. I think that's really where all my confusion is coming from. Because this is this. Just because these only bridge one gap, I can't put them anywhere else. I could always make a perforated board that would do that, but whatever. Whatever! Here, let's move this like this. Just so it's, And I gotta keep it on this side because I'm gonna be building the same thing over here. So that one goes to a 100K, that goes to a 10K, that goes to the partner capacitor to this. So let's do, so that's well, suppose a 100K, an adjustable 100K, goes to another 10K, and that only needs to go one junction. Yeah, people are still going outside, so I can't open my window. Freaking dying. The sliding door keeps opening and closing, which is driving me insane, to be fair. Driving me completely insane because all the rollers are right over my head. So I hear, whoo, you guys don't hear it because I've filtered my mic properly. Okay, 100K, 10K, then the other capacitor. So I'm just using these as placeholders. The other capacitor. And then that goes all the way to the wiper pin. How in the hell? I think I'm going to have to go through and under. This is a wacky circuit, guys. This is a wacky circuit. Because, I mean, I couldn't add that capacitor to the wiper because it only goes over one circuit junction. So it's not going to work there. I mean, I can use a longer wire and go through the tunnel, basically. This is too long. Well, I might have to just move this in one. And then I'll just go around the outside, around the outside, around the outside. I don't really want to go around the outside, around the outside, around the outside. Yeah, it's too long. All right, let's see if we can go in the centerpiece. I don't know if this is gonna help. I don't know if this will be doable. I just dropped something. I don't know what that was. Too long. What about blue? What about the blue? Blue might be able to do it just on the surface, but that's going to make it a little bit too confusing to look at, right? Blue would go from there. Blue can't quite reach. Maybe gray? I think gray is a little bit longer than blue. Brown is a little bit longer than blue. Brown would really confuse things, though. I don't think brown's going to reach. Hold on, wait. Not quite. Not quite. Brown makes it back to the chip. No further. But no further. Yeah, it's just going to be another orange jumper, huh? Just another big, hideous orange jumper on the outside of everything, unfortunately. In order to bring that signal all the way back over to here. Orange is way too long for it, though. But I don't have anything in between. So that's just what it is. At least the input and the output are on the two sides of that, so I'll be able to wire that up. But, yeah, that's obnoxious. It's kind of ugly. There's nothing that, like, fits the bill. I don't have anything in between. I need to get another jumper kit is my problem. Is gray a little bit more civilized? It's like the same length. It's just barely. So I was thinking I could go under the chip. That would clear it up, wouldn't it? If I take this out and I just go from here to there. Oh, there's too much. Needs to be shorter than that. I don't have anything. I don't have the right sizes. I'm just sitting here complaining. Here, wait, come back over here. See what I'm doing. I'm trying to make that jump, but it's my wires are too big. I don't have 1 ohm resistors. Those would be great. Yeah, it's like not long enough, too long. Everything else I have is too long. It's not going to work. Shame. My clean circuit is not clean. Okay. Because I've overextended myself. Or underextended, I don't know. You could always make that go a huge distance and then this will suddenly work out, but I don't want to waste space, you know? So we will just use the gray jumper, but I'll use it on the outside. And it'll be this hideous... Oh, wait, no. I lost part of the gray jumper, huh? Too many flexes. They only have so many bends in them. Make that. Now it's a slightly shorter jumper. That actually almost works in this application. It actually works going inside, but I can't modify a bunch of them to do the same thing. So I'll just do it on the outside. Do it on the outside. It'll be fine. 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 This goes there. This goes there. Yeah, that'll just have to be... Okay, so that's where that goes. We're almost out of time here, folks. Nah, I got a little bit of time. I just hear shuffling and it, like... Keep thinking that... It's closing time, but it's not! Okay, so that's one side of the circuit, minus the input and the output. One side of the circuit minus the input and the output. Hello? Nope. I overshot. There you go. I have a Stream Deck that sends commands over Node-RED to an OBS WebSocket connection, and that allows me to do all these adjustments. Like, it allows me to alter focus and things like that. All right, one side of it, we've got sacrificial capacitors whose values are not really known. They're the ones that I pulled out of the other part of the circuit. All of our junctions and connections are done. Looks like it. Two 10K ohm resistors to ground. One of them goes to the junction of the two 100K ohms, and then that one has a 10K ohm resistor coming up off of it that goes to a 22 nanofarad, at least in the values that we were looking at, capacitor that then goes back to the center wipe of the adjustment. The output of that, which is on pin 7, 1, 2, 3, 4, 5, 6, 7, this one right here, the output of that also has a 2.7 kilo ohm resistor that goes to pin 6. Pin 6, 1, 2, 3, 4, 5, 6, 7, 7 and 6, 2.7 kilo ohm. 2.7 kilo ohm also has another 2.7 kilo ohm, so go up here and back down to the other 2.7 kilo ohm, and that goes into the other side of the wiper, which is also the input. All right, so far so good. Let's see, the junction between the two 100 kilo ohm resistors that are supposedly supposed to be adjusted in tandem with one another. That all has the same junction, which is on pin 3 or pin 6. 1, 2, 3, 4, 5, 6, pin 6. Pin 5 in this case. Oh no, sorry, it's pin 5. Yeah, pin 5, which is this one here. So it's jumping down here because it's got a capacitor that goes to ground. Well, that could actually be moved up a row if it needs to be. Whatever. Okay, that jumps down there. This one is one of the 100. That's the other 100, and that goes up, blah, 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 blah. And then this other one goes to ground immediately. And it doesn't matter whether or not it has that jumper there. Hey, Terts, what's up? Okay, so that checked over is one half of our circuit. That is really sloppy, and I don't like it at all. The forcing the one jump is really causing things to kind of look weird in this case. I mean, it was that, or I physically solder it onto a board and spread it out. So on this side, we have part of the circuit put together. I at least have the capacitor going from, well, the 2.7 kilo ohm going from, where is that? So that one's going there and there. That one, 2.7, and then the other 2.7 that goes from pin 1 to pin 2. Pin 1 to pin 2, 2.7 kilo ohm. The other 2.7 goes to the wiper of the pot. Good. Okay, so we need to build up the middle part, which is the annoying part. Alrighty. Alrighty, righty, roo. Now what I was doing there is, if you don't know what's going on, you want to know what I was doing in electronics, I'm going through each individual junction of that circuit, and I'm figuring out whether or not I have the stuff properly installed. Thank you for the follow. So I'm looking at, okay, pin 3, what does pin 3 connect to? Pin 3 goes to that unholy amalgamation, that eldritch horror of multiple connections on one bar. And then I'm looking at, okay, what's connected to that? A 100K that goes to this thing, and then a 100K that goes to this thing. And just kind of piecing through the circuit as I go, just to make sure that everything's connected properly. So what we're doing now is we're hooking up basically this portion of the circuit to the other side. And I've already got the 2.7Ks in there. So what I need to do is I need to go from the center pin to a capacitor. So how did I do that before? I jumped all the way down here. I'm basically repeating this structure. And actually we can do it pretty textbook, because if I jump that out here, this becomes the same thing as the other one. So I need to jump over 3 pins. For that, I got blue. I need to find a blue junction. Where he at? There we go. There's one. Running out of them. I'm running out. Okay, so that just jumps over that pin, which is ground. Yeah, but if that pin is ground, we actually, well, okay, so first of all, I need to get my signal out of there. So this would be pin 3. So getting pin 3 out of there is priority number 1. Priority number 2 is one of the companion capacitors that's going to select the frequency that this thing works on. So I need a stand-in for a capacitor. I could take a capacitor from one of these filters and use that. Well, I guess I will. Companion capacitors, there we go. So what we do is we can take this one and go to ground. So there's our capacitor to ground. We also have 2 resistors to ground, but we'll do that in a sec. We have 2 100 kilo ohms, so I need 2 sockets that are going to be our stand-ins for the hundreds. I need to cut some more sockets. I'm like tired. This is getting to me. Like puzzle fighting. Those will be our stand-ins for the 100s. One of them is going to go right like this. And then that gets a 10K to ground. And then I'm going to need another jump for this thing. Oh boy. Another yump. That's getting hot in here. That just gets 10K to ground, and then I need to jump over that again. These little crossings are starting to get to me. The only like I could build the 10K resistors into the values that we choose. It just depends on what's findable, what's available in terms of resistor values. So if that, value plus 10K is hard to find, then I have to incorporate the 10K ohm resistor. Elliot of Elliot Sound intended for this to be adjustable. So I'm taking out that adjustment. So let's see, what does that get? That gets another adjustable, then a 10K, then the capacitor. So adjustable goes right there. I could do this in a row of 6 pins, neat. Then the resistor, then the capacitor. Yeah, I could do that in just a big row of 6 pins, huh? That's kind of cool. Maybe I could just put all 6 of the pins in there and have all the values in one thing. 10K. 10K. 10 kilo ohm resistor. Bend it down and then clip it. Clip it. Clip. Clipped. It has been enclipped. Can I apply this lesson to the other one? Of having just a big row of pins? No. I don't think so. That capacitor goes there between those, and then I've got a jumper over here that brings this value to here, here to here. I might be able to do that. I might be able to rearrange these so that everything is that capacitor is supposed to be to ground. The ground is right there. If I did that over here, yeah, I could probably do that and just have a big row. Just like how clean it is. Move this out a little bit. And then this has to go all the way up to here somehow. Gray wire. Like that. And my input and my output are kind of chunked in there, aren't they? Wait, what is... That one doesn't go anywhere. Oh yeah, it does, because it's got a jumper under here. That's right. Oh man, what a mess. Well, the problem is, Dion, the problem is that I don't have... Oh man, I'm getting tired. The problem is I don't have dual potentiometers like this. I don't have dual adjustable, you know, what is it? The potentiometers that you can like stack up. I don't have those. So I'm making them fixed value because I mean, I figure I'm not going to be futzing around with the frequency very much. The frequencies I want are fixed. The adjustments I want are probably fixed too, but I want the option to be able to move them around. So I'm going to make each filter stage is going to be like a decade. That's close enough to what I already have so that I can replicate this filter. I'm hoping that'll be the case. I'm hoping I'll be able to do that. Replicate this filter so that with the fixed frequencies that are pretty much just every decade, right? So my mic sounds correct, you know? Oh man, that's one filter? Are you kidding me? Look at that freaking crap. It's all over the place. Now I could replace... I could actually put a fixed piece of header pin in this, and I could probably do the same for the other one over here and have that all worked out with stuff to the side. That would be a cleaner way of putting it all together. I'll leave them separate for now. They just don't seem to like to go next to each other like that, but I can definitely move around some of the stuff over here to make them both resemble, and then that way I've got kind of like a form that I can follow. It's easy for me to kind of like alter stuff, right? And I know approximately how much room each of these stages take. So I'm probably going to have to build another stage up here. We can disconnect this from the rest of everything. Actually, I should keep this wire on the right. I don't remember where that goes. I think this is the loop that we break in order to run our own stuff in. So you can build doot, doot, and doot. And so by the next stream, I will have the 3 circuits of this built. I may want to run that one line under. I may make it just my own wire to do that. I don't have this stuff lying around. Maybe I could just alter these to do that. Because if I'm going to build this thing 6 times, it's going to be torture. It's going to be torture. But I can replicate this circuit, and then we can roll from there. What's nice about it is that all the through-hole resistor values are just 10K. Custom PCB is after we test this. If this works properly, then we make our own custom PCB. I mean, I could also look up like a filter design that could also support this, like a PCB that'll take a filter and do, you know, give me all the places to mount these things. I don't know if this is a common design. This is probably not a common design, but there are probably like prototyping boards that would let me build this and then have blocks that I could put together. But I'm not gonna show the repetitious stuff that I'm about to go through. What I'm basically gonna do is figure out, because I've got 6 of the filters going in, I'm gonna cross-reference the Elliot Sound Project, and I'd hope this would go together faster, but it's just not. So what I would do is determine. This is giving us a rotation and what frequency range. I'd have to figure that one out. He probably should have given it a resistance value. He gave it a rotation value. So here are the capacitor values for the range of values that can be adjusted, and then I'll have to figure out what resistors then go into that. That's going to be tough. I'll try to figure that out and get all that together. It's a lot of work to do on Wednesday, man. I'll have to sit down bright and early with a big pot of coffee and just get to work on this, because I want to build the rest of this, and then I want you guys to be there when we test it out. So that's what I got to work on. That wasn't as exciting as I wanted it to be. I was hoping it would go together faster, frankly. Frankly, I was hoping it would go together a little bit faster than that. This is a little tedious today. A little tedious today. But I'm going to wrap it up. I'm not going to draw this out. We're doing more solderless breadboarding. I'll do more on my own. I'll do the repeat structure. We'll plug it in and work with it next week or earlier. It depends on what we get up to. Saturday, I want you guys around on Saturday. Julian's going to be here. We're going to be building something for him. I'll be able to show off my soldering skills a little bit more for once. It's a fairly easy kit, but we got to get him in here and out of here very quickly because there's going to be people over at night, and I don't want to talk to like random people, you know. So he comes in, he builds the circuit, we have a good time, then I kick his ass out. But that'll be Saturday. You guys got to join me on Saturday. I don't want to embarrass him by having 4 people watch. All right. Anyway, I think I'm just gonna end. I'm just gonna end my stream in Minecraft. What do we get? What's he doing? Crusader. No. Davies is of course playing my summer car. All right, I'm going to be back on Thursday. Wednesday, I'm going to work on this stuff off air. I'll be back Thursday. Thank you guys for the follows. Thank you guys for the subs. I don't have my gimmick for subs right now, but we'll get that working. Working on that on Thursday. All right? No, the Minecraft reference is something that, I don't know, maybe other streamers do it too, but it was Adam Plays thing about certain language being against toss on Twitch unless it's in Minecraft, which I guess gets you around stuff. I don't know. So that was part of the joke there. I'm ending things in Minecraft. No, anyway, I'll be back on Thursday. We're going to be working on Fusion 360, which is its own animal. That'll be fun. And we'll get something together that I can actually 3D print so that we can finish this freaking board on my wall. I'll see you guys then. Have a good one.